Hey everyone, welcome back. Today we're having a good old flat Earth debate. We have with us, let me get, you told me earlier but I pronounced it wrong, Michael Aftias, who is going to be representing the flat Earth side. It's nice to be in the room ready to go, more than most flat Earthers managed so far. So thank you for being here. If you haven't already, make sure you like the stream, share with your friends, go in the street, scream at some random that they should watch FTFE or you'll take the family hostage. Don't do that, you'll get in trouble. So we're about to do the thing where I play an intro, right? So if you're watching this as a VOD later on, you can just skip like the next, I don't know, 90 seconds. But if you're here watching live, you don't get a choice, and there's going to be music. So the rule is that you dance. If you don't dance, I'll send Daniel Pratt to your house. If you do dance, I'll send you a cookie.
On a disk, floating through space, with a tiny sun.
So everyone, welcome back. Hope you're doing well. Happy, what is it, Monday? Are we on Monday already? Yeah, blue neck. I've been very busy over the past week with the school holidays, the kids taking up a lot of time. So sorry if I haven't been here as much as normal, but we are back with a flat Earth debate to just ruin the beginning of your week. Sorry about that. We've got with us Michael Aftias, who contacted me himself on Facebook, which is a rare thing to happen. Thank you, Nick, for the super chat, $4.99. Remember to call out double standards and hypocrisy any chance you get, which will be the whole debate. Well, we'll see. I like to give people the benefit of the doubt to start. You know how I work. They decide how the debate goes. They're decent to me, I'll be decent to them. They act like a dick, I bring out FTFE. And appreciate the super chat support. If you want to help support the channel, of course, super chats will be read out at the end of the debate. Questions for Nick, I will put to you. Obviously, I'll try and get through as many as possible. If you super chatted, they're the ones that go up first. So if you want a question for the Flat Earther, feel free to super chat and ask. But we'll get him on to say hello. Michael Aftias, welcome to the channel. How are you doing?
I'm doing well.
All right, thank you very much for joining. You contacted me on Facebook. Normally, it's me trying to chase down the flat earthers that are scared to come and debate. So it's nice. You said this is the first time you've done a live debate.
Yes.
Yeah. How long have you been debating flat Earth?
About 10 years or so. I guess just kind of with friends and family and people that, found out that I don't believe in heliocentric theory anymore. It just doesn't always turn into a debate, but I've had people ask me questions for 10 years after a decade of it, kind of a lot of them do, it challenges their core beliefs so that, kind of upsets a lot of people. Even just finding out it's kind of odd, but not so odd when you understand how the core values and everything factor into it.
Right. So you've been a flat earther for 10 years.
Yeah.
Do you just want to take a minute, introduce yourself, tell people what exactly your position is on the Earth and the shape and the motion and space, etc. Tell everyone exactly what your position is, and then we'll just get into showing some evidence for it.
Okay. I know that I live on a flat and level plane in an enclosed electromagnetic field. I don't believe Earth moves. I think it's completely motionless. Uh, and that obviously, the sun and stars, everything moves above us. So,
Oh, is that it?
yeah.
Okay. And you say
would-
you have evidence for this.
Yeah.
Excellent. Well, I said I'd give you 10 minutes to show evidence. So have you got things you want to show on screen? How are you going to present your evidence?
I'll just explain it. Should be, I mean, this is evidence that anybody can observe with their own two eyes. So it's not very hard to
Right,
convince
but you're
or-
not actually going to present anything, any science, any physics, any studies.
I could
anything people
demonstrate it as well.
Check. You just
Yeah, I can demonstrate it here
okay,
as well.
all right. I'll give you 10 minutes. So if you want to start in the next 3 seconds, you'll have 10 minutes from then.
Okay. Well, the physics of water, the surface of any large body of water is flat and level. I mean, you look at a swimming pool, surface is pretty flat. The idea that it would curve at some distance, I mean, this is something you really got to believe because no one's ever measured it. There's a big misunderstanding about, how your eyes actually work when they look at a horizon over the water. And, people see something sink from the bottom down, and that's just perspective. Something's above your eyes. As it moves away, it appears to get closer to the horizon. If it remains above your eyes, the bottom of the object is going to compress before the top of it, and that's just due to the angular resolution of it and its angle between your eyes and the object. Yeah. And I guess the other part is Earth is definitely motionless. There's no speed to Earth rotating or moving through any kind of void in space. No one's ever measured the speed of Earth because to measure speed, you have to observe an object move a distance over time. That's pretty well known as far as how we calculate speed is you have to observe something move from point A to point B over a period of time, and then you can break that down to miles per hour, kilometers per hour. Nobody's ever observed Earth go from a point A to point B. Ever. So you can't measure the speed of something if you can't observe it move a distance over time. And that's just a fact. I mean, you could speculate and use relative motion as an excuse, but you simply cannot measure the speed of something if you don't observe it move from A to B. That's just a reality, in my opinion. I know we all have different opinions, but yeah, I guess that's about it.
Well, that's 2 minutes 27 seconds, and I haven't seen any evidence.
I could go on for hours, but I think those two are really the only ones I need.
I mean, to be clear, you haven't given any evidence. You've made some claims. Claims aren't the same thing as evidence.
So you see how the surface of that water is flat?
It's level.
You see how it seeks its level, right?
Yes.
And a large body of water requires a container, and it takes the shape of the container. It doesn't stick to the outside of the container.
Again, claims, not evidence.
You're observing this right now, though.
That's not a large body of water.
This is not a claim. I'm demonstrating it for you so you can see how the surface flattens.
That's not
flattened level.
Not a large body of water. That's bottle of water it's water in a bottle in a small amount.
It's the same fluid.
Yes, but did you measure the surface of that water?
I guess the better question would be, how does the distance affect?
Well,
how would the distance affect it?
It will curve more over distance. Did you measure?
What curves it?
Let's just be
at
clear.
a larger distance, though.
You made the claim that the
And
water in
I
that bottle was...
demonstrated it.
No,
Yeah.
hold on. You made the claim that the water in that bottle was flat. Did you measure it to check? Any evidence to back up the claim that you made other than it looks flat? Did you check with any precision? What instrument did you use? What units are you measuring? How many decibel points are
I
you
could get a
doing?
ruler.
Yeah,
and
and how accurate is
measure the flatness
a
of it.
ruler compared to the distance? You know, so let me try and help you out here. Sorry, let's assume that the water in that bottle, when it's still, curves with an arc matching that of the curve of the Earth. Do you know how much curve it should show over that diameter of that bottle?
With the 8 inches per mile squared.
No, that's not curve. That's drop from a tangent.
You're trying to minimize it down to the bottle.
Well, yeah, so that you can check what it should be. You know, when you say, well, that's flat, here, look, it looks flat, evidence then is the measurement to show that it's flat, because anything can look flat if you're not able to, over a certain distance, perceive the you know, the amount of curve there is, but you check. That's why machinists have to check, like, down to the, you know, micrometer precision when they're doing things.
So you think the surface of a swimming pool is curved somehow?
Well, this is your evidence. I'm not giving my evidence right now. I'm just asking for your evidence, and you've made a claim that the water is always flat. No, you said
are
you
you
demonstrated
unable
it
to
looking.
observe?
You demonstrated it looking locally flat, but you haven't checked, measured to check. You've just said a thing and made a claim. To what margin of error is that flat?
You're suggesting that people aren't capable of observing a flat surface.
Not to any precision.
Flat
Your eyes couldn't
their-
tell the difference between 0 and 0.0000001 degree. You need tools to measure when your eyes aren't good enough to see something that minute. That's why I asked you,
used any tools
because
to
that's
measure
your
this
evidence.
curve that you
Because
claim
yeah,
it should
when I
be
get
at
to
that
my evidence,
distance?
when I get to my evidence, I can show that. But if you're using a bottle of water, you need to do two things. One, provide the prediction that my side claims. So what would my side claim is the curve in that bottle of water? To how many degrees? You don't measure curve in 8 inches per mile squared. That's a drop from tangent. But if you're measuring curve, like how many degrees, how many radians is it? Should it be if the Earth is a globe and that water is curved? And then you do a measurement to compare it to our prediction, because that's how science works. You try to disprove a hypothesis and a prediction from that hypothesis. So if you're using that as your evidence, what does my side claim is the curve in that bottle? How many degrees?
So you're trying to use a claim as a basis to compare against the already observed evidence.
No, I'm trying to do science with you, which means you have to make a prediction using a model that, my model says that there should be a curve equating to X degrees over the distance of that bottle that you showed. What does my side claim about the water in that bottle? How much should the water in that bottle curve?
You know? Comparing, you're talking about the same fluid. So if it doesn't curve, if it's that flat in the bottle,
But how flat is it? How flat exactly is it in that bottle? To what, to the nearest
It's the- it's how the surface
0.00001
of
degree,
water-
how flat is it?
brother, you can get any container of water and move it around.
This is a claim.
When it's at rest, the surface is flat and level.
That's a
This isn't
claim.
up for debate.
Well, it is. It is up for debate. You're making a claim about it, therefore it's up for debate. Do you have a measurement of water in a bathtub? What's the chord length of that zagita that forms? The hump that would be there. What's the arc length of that? What drop over tangent would you expect of that point, and how would you determine that? Well, how many degrees of curvature is there? To what radians could you measure it?
As flat as you can get.
That's not a number. To what margin of error are we talking here?
Okay, I'll wait to hear your evidence
if, like, for instance, 0.00000001 degrees is pretty flat, but it would still eventually form a sphere, even though it's close to flat. So how flat are you talking? Because for your claim, it would have to be an infinite zeros, never with a 1. And how have you tested that? How have you
never with
measured
a 1, it can be 0.00000001.
No, because then eventually it would form a sphere. Might be a very big sphere, but it would still form a sphere.
Might be way bigger than, 8 inches per mile square.
So what are you claiming the Earth is? Are you claiming the Earth's flat or just a really big sphere?
We live on a flat and level plane. So there's only
that's
one
a claim,
up above us
but you
and
haven't
one
given
down.
any. Your 10 minutes is up, and you provided no evidence. You just said water is level. Look at a swimming pool.
I demonstrated the physics of water.
No, you showed water reacting to the force created by gravity.
You also saw water.
Understand. But you didn't present me any measurements.
Water required a
something.
Container.
Yeah,
the water did require
because it has to be away from the other container that's trying to pull it towards it. Yeah.
What other container?
Well, the Earth.
So you're saying the Earth is an enclosed system?
No, the Earth is a container because the force created by gravity holds the water to it.
Gravity.
Yeah.
Gotcha. Which gravity do you subscribe to? Is it Newtonian or
Which
Einstein?
Xbox do you play Call of Duty on? Is it the Xbox 360
I don't
or the
play
Xbox One?
Xbox.
Okay, which PlayStation do you play Call of Duty on? PlayStation 4 or PlayStation 5?
They're two very different ideas.
No. Which one?
Just so we're on the same page, I'd like to know
which one. Because they're not different ideas. One is simply an upgrade to the other one. It superseded it, but Newton's gravity worked perfectly on a local level. And what is Newton's gravity? Do you know?
Yeah.
What's the formula?
Are you talking about measuring the gravitational force of an object on Earth?
I'm asking. Well, Newton's law of gravity is what we would normally talk about. So, what is Newton's law of gravity?
Mass times acceleration. Are you talking about?
No, that's force. That's just for a force. What is Newton's law of universal gravitation?
I'm asking you to calculate the gravitational force of an object here on Earth.
No, just what is the universal law of gravitation?
M1, M2 divided by the distance to the center of each object. Is that the one you're talking about?
Squared, yes. Yeah. So that works perfectly on a local level. However, if you want it to be a lot more accurate, you use Einstein's much more accurate version with his tensor equations for relativistic things, extremely massive objects and things traveling really fast, because then Newton isn't accurate enough. They both do the same thing. In fact, you can derive Newton's law of universal gravitation from Einstein's 10 tensor equations for gravity, so they do break down to the same thing. However, Newton didn't know that the gravity traveled the speed of light. He assumed it acted instantly, which for all intents and purposes, because the speed of light is so fast, still works on a local level. That's why engineers calculating the force created by gravity when making a bridge would use Newton's universal law of gravitation and not Einstein's tensor equations.
Okay. Einstein's idea of the whole time-space thing is mathematical
space-time
format.
Time-space.
Space-time, yeah. It's just math. It's not...
It's demonstrated to be
evidence
shown
behind
in
it.
Experiments. But again, you're making claims. You didn't do any evidence. Shall I show you what presenting evidence is?
Sure. Well, let's go back to your gravitational... the formula for calculating the gravitational force of an object here on Earth, which... Newton's formula would suggest that the mass of an object determines the amount of gravitational force would be on the object.
Yeah, that's why if you drop a 20 kilogram on your weight, on your foot, it's going to hurt more than dropping a 5 kilogram weight on your foot, because one, having more mass, has to have more force applied to it to have the same acceleration.
You could have two objects that have the same mass and different densities, and when you set them on the surface of water, one is going to sink.
Because float. Buoyancy is a thing.
They could both be 1,000 kilograms.
Buoyancy is a thing.
If you have 1,000 kilogram rock this big and 1,000 kilogram boulder that's just ginormous, you get one's going to float on the water, the other one's going to sink straight down due to density.
That's buoyancy, which is a result of gravity.
No, Archimedes calculated buoyancy way before.
Well, no, he just said this is buoyancy, and he didn't. Yeah. He didn't calculate.
So saying buoyancy is reliant upon gravity when it was already calculated.
No, he didn't calculate rho vg.
It came around.
He didn't use acceleration.
Buoyancy.
No, he didn't calculate buoyancy. He calculated the
Who?
displacement amount.
Archimedes?
Yeah, to calculate buoyancy, you need the downward acceleration created by gravity.
You don't. You can actually calculate it just fine without throwing in that gravitational constant, which
No,
is just a number.
No,
So
it's
when you
not
talk
gravitational constant. Wait. It's not
ahead,
gravitational
go ahead.
constant. It's the acceleration created by gravity, which is different depending on where you are on Earth.
Oh, so it's a number now. Gravity's a number.
G. The G in the buoyancy formula isn't the the gravitational constant. It's the G for the acceleration due to gravity. You do realize that different letters can represent different things in different formulas, right?
You know, that's like the same number when they reference G.
No, it's not the
like
same
the
number.
same
One is the
number.
universal. One is the constant, the gravitational constant, big G, next to M1, M2, and one is little g, which means the acceleration due to gravity on Earth.
How can something be simultaneously a force and an acceleration?
I didn't say it was. Big G is not a
Yeah.
force either. Big G is the gravitational constant.
How can there be acceleration due to gravity while it's a force acting on it? It can't be the force
No one
and
said
the
that
acceleration
gravity's
at
a
the same time.
force.
You're saying gravity is not a force.
Gravity creates a force.
So gravity is a force.
No, gravity creates a force. The force of gravity is the force created by the gravitational attraction.
So you're saying
Right, so let's be right.
gravity
So
creates the
I think
force,
what we need to do first of all is explain to you the
but
difference between
isn't
the
the
things.
force.
Hold on. Yeah, like an engine creates a force, but an engine itself isn't a force. One thing creates the force, right? But you seem to be confusing units here,
like
right?
my engine makes the horsepower,
Hold on, wait,
but it doesn't
wait,
make
wait,
the
wait.
horsepower.
You're confusing units here. Let's be clear, right? G, the first G is when you have F little g next to it, and that just stands for the force of gravity, right? As in the force created by gravity. The next G in the formula is big G, which sits next to M1, M2, which is the gravitational constant, which is the ratio that they use to convert one thing to another. The next G that you're talking about is the little g that we use to define acceleration due to gravity on Earth. These are three different things, and you're talking like they're the same thing. So you need to understand the difference between them because you're getting confused with the most basic of things, which is
No, I
why you
understand what
failed
you're
to
saying.
give
You're
any.
suggesting that
which is
gravity
why
is
you
a
failed.
force and an acceleration.
No, I literally just told you gravity creates a force.
So big G is gravity and little g is gravity, right?
Big G is
According to you.
gravitational constant. Little g is the acceleration on Earth due to gravity. Big G is not
Now,
an
you know-
acceleration, it's a constant.
When you type
Do you know
the
what
mass,
a constant is in a formula?
Yeah,
Tell me
When
what a
you-
constant is in a formula.
it's a constant. It's the same number.
And what if the other numbers change? What happens to that?
It remains the same.
Right, okay, so you understand that won't change, big G, because that's a constant, whereas little g,
Mm-hmm.
acceleration due to gravity on Earth, changes depending on where you are on Earth because of the variations in the gravitational field.
Yeah, okay. Now, when you use that formula and you put the mass of object one, which would be M1 in the formula, or because the other one, the M2 is going to be the mass of Earth, because that's where you're trying to calculate the
Well,
the
M1 would
gravitational
be the
force
mass
for
of
the
Earth,
object
and then there
while
would be
it's on
another
Earth.
one, yes.
So that would go, the radius at the bottom of that equation, the r squared, that is gonna go. That's the distance between, the object here on Earth and the supposed center of Earth, 2,000 miles. That's supposed to be 2,000 miles below us, which is a wild claim considering the deepest we've ever been into Earth is only 8 miles.
Okay,
so
you're
to
changing
claim
the
that you know
subject
what's
now.
going on 2,000 miles below.
Yeah, seismology
into
is a
Earth
thing. Yeah. Do you know that we can look inside a
yeah.
human and see what a baby looks like?
And you could totally look inside of Earth with the
Yes,
same
it's the same
precision.
concept. Yes, it's the same concept.
Really? I'd love
Yeah.
to see those X-rays of Earth.
Cool. It's not.
Yeah, but-
Well, a sonograph isn't X-rays. It's bouncing sound waves into the belly to image the thing, which is what we do with earthquakes. There's an entire science around it called seismology.
Yeah, and you bounce these sound waves 2,000 miles below us into Earth.
Sorry, what was that? I mean, you still haven't. Right.
You-
Anyway, you failed to give evidence. Just so you know, I'll show you what giving evidence is, because you made claims, you didn't give any evidence. So if you bear with
let
me,
me finish the part about your formula on gravity and how
you don't understand
the
it.
mass.
No,
No, I do. I'm explaining.
Well, you didn't
it to
understand the
because
difference
if you put the
between the
mass of
different
object
Gs.
1 and the mass of object 2.
Yes.
The higher the mass of object 1 is, will give it a higher gravitational force.
Yes.
When you calculate it, right?
Yes.
But you can have two objects with the same M1. They could both be 1,000 kilograms for mass 1, but one will sink through water and one will float.
I told you that buoyancy is a result of gravity.
So you see how the gravitational force, that F, doesn't
again your
because
buoyancy is a force, right?
Why does one have a stronger pull than the other?
It doesn't. Buoyant.
They have the same mass.
I've said it several times. Buoyancy.
But they have the same mass.
I've said it several times. Buoyancy.
Pulling the object down.
Buoyancy, which is a result of the medium and the downward acceleration due to gravity. Hey, I'm talking. Right. Yes, they're both being pulled down with a stronger or bigger force depending on the masses, but the same acceleration. Right. Let me finish. I'll let you know when you can talk. Okay, I don't have to mute you. Right, they're both being pulled down with the same acceleration, but different forces because they're different masses, right? But then it also depends on the medium that they're going through and the resistance that gives thanks to the acceleration due to gravity. When there's a bigger medium, like in water, there's a higher buoyant force acting in the opposite direction. Are you aware of the concept of summation of forces? It's a yes or no question. Are you aware of the concept of summation of forces?
Yeah, you could put all the forces together and come up with whatever calculation you want.
Right. Okay. So there is the force created by gravity pulling it down. Mm-hmm. Then there is the force in the opposite direction of gravity due to buoyancy as a result of gravity, which is going in the opposite direction. So overall, the one with the higher mass actually has the higher buoyancy as well. Well, with the higher density, has the higher buoyancy as well, because it's a result of the medium and the thing putting it down through the medium. So if you've got a thing with a bigger surface area, or that's less dense overall, it will have a higher buoyant force acting on it because there's more fluid being displaced. Right? And that's what buoyancy is. It's the medium's being pulled down with a stronger force than the thing because of the density, which makes a force in the opposite direction. So yes, but that's why you can use a vacuum chamber and drop a feather and a 10-ton weight, and they both hit the ground at the same time. But anyway, you failed to give evidence. You failed to give evidence, and you failed to demonstrate you have any knowledge of physics. So I'll show you how it's done and give evidence of the shape and motion of the Earth and the claim that we make.
You're not going to let me finish my point, are you?
You finished your point.
We've established that two objects with the same mass.
I just explained it for you.
Yeah, they'll have the same, but they have the same gravitational force.
No, they don't. They have a different gravitational force because one is bigger than the other.
Okay, here's M1. Let's say it's 1,000.
Oh, sorry, you're saying they've got the same mass, but they're different buoyancy.
Yeah, they have the same mass.
Yeah,
so one will sink and one will float.
And that's
if
because
they have the same mass,
again,
then
if it's got less density, it's bigger overall, and like I said, that means it's displacing more fluid. And the buoyant force depends on the amount of fluid displaced as much as it does the mass of the object and the acceleration pulling down. If there's more fluid if there's more fluid being displaced, then the stronger the buoyant force due to gravity acting in the opposite direction. That's the point.
Oh, yeah. See, for that, you have to calculate density, which is mass divided by volume, right?
Yes.
Okay.
Yes, there's variables in the equation.
There's no P. P equals M over V, right? Well, there's no P in Newton's formula for gravity. It uses M1.
P equals M over V.
And M2, right?
Sorry, what's P? Say the P again. P equals what?
P equals M over V.
P is what?
Density equals mass over volume.
So you mean rho?
Well, I'm sorry.
It's
I'm
not
giving
P,
you the formula for
it's
density.
It's not P. It's the Greek symbol rho.
My bad. It looks like a P, right?
Yeah, but it's not P. And if you knew what you were talking about, you would know that it's not P, it's rho.
Oh, yeah, if I knew what I was talking about. Okay. So this, when you have M1 at 1,000 grams
they're different
M2,
things. Rho is the calculation of... Right, let me answer it for you. Right? Rho is the combination of the mass of the object, the volume of water it displaced, and the acceleration. These are the things that make rho, and some of the components of that are the same as the components for the force of gravity. That can happen. But rho doesn't have to be in the force created by gravity, because rho is buoyancy, not gravity. It's a different thing.
Okay. If the two objects have the same mass, they have the same... That'll calculate out to the same force, right?
Yes, I've just explained that to you, but they have a different surface area, right? Because they're less dense, so they displace more fluid. I've just gone through that with you.
Yeah. But why would one object... So where would you use Newton's formula for gravity? Why would you even bother calculating it when that doesn't determine if it floats or sinks? It has no bearing.
Because it's part of it that you would be able to calculate
medium.
You would be able to calculate the force of the force due to gravity of the object, and then you could compare it to the other things and do a summation of forces. You can't just say, well, that's not the entire thing. It's part of the entire calculation. You get the force due to gravity. You wouldn't compare it. You would do a sum.
You don't need it for density.
Yeah, but then to know if something's going to float or not, you need to know the force that's pushing it down as well.
You would need to know how much fluid it's going to displace.
Yeah, and the force also.
Mass equals volume.
Yeah.
Or density equals mass over volume.
Yeah, but
right?
There's
no force in there.
The force would be when it was going down, and you could calculate the acceleration. Right? You can calculate the force by the mass of the two objects being attracted to each other and doing the universal law of gravitation. The force is still there. It doesn't disappear, but then you also have to calculate the buoyant force, which means that it will float if the buoyant force is higher than the force created by gravity. Or the acceleration, obviously, of gravity, and then the acceleration due to the force of buoyancy. Because you get the force of buoyancy, which you calculate rho vg, right? That's how you calculate the force of buoyancy. And then you get the force created by gravity, which is Fg equals gm1 m2 over r squared, right? And then you compare those forces. Then you compare those forces to the masses, which gives you the acceleration. So you'd have the acceleration due to gravity of the object pulling down. Then you'd have the acceleration due to buoyancy acting in the other direction. And then you subtract one acceleration from the other, and you get a positive or negative acceleration. You need to know the forces to know the acceleration that's going to happen when you have the masses. But the way
you had the electrical forces acting on the object as well, right?
The electrical forces are minute over those kind of distances and sizes.
Oh. I didn't know.
They're literally zero at that point, as close as it can be.
Oh.
The electric force is only strong at like subatomic distances.
Yeah, you're surrounded by... There's electricity in the air all around you.
Anyway, so have you finished your point? We'll get to your woo that you don't understand in a bit, but if you finished your point you were trying to make about gravity, do you understand? I've explained it to you now.
You haven't.
Anyone with a brain can know. I'll summate for you. I will summate for you. You have the force.
What are you comparing this number with? What are you using to
Let me go through it one more time with you. Pay attention.
Yeah.
You have the force created by gravity, which gives
what do you do with that number?
Do you want me to explain? Or are you going to keep? I'm going to explain what you do with the number. You get the force created by gravity, Fg equals gm1 m2 over r squared, and you use that and the mass of the object, right? And then you get the acceleration due to gravity towards Earth, right? Then you get the buoyant formula to do the opposite side. So the buoyant formula is rho gv, right? Which is obviously the density of the object, the amount of volume displaced, and the acceleration due to gravity, right? So you use the buoyant formula, which you get from those things, and then times that by the mass of the object to get the acceleration acting in the opposite direction to gravity. Then you take one acceleration from the other, and you get either a positive or a negative acceleration to show you which direction the object will go, depending on the fluid that it is in and its density, because of gravity. But
Right.
the students that I tutor get this.
You know, I don't know what they're getting, because you're saying that you basically calculate the force of the force of gravity on the object, and then you throw that number out the window.
No, you use that to calculate the acceleration in one direction.
Buoyant force, and the buoyant force is what's going to tell you.
No,
because
you need both of them.
The gravitational force can be the same for two wildly different objects.
Yes,
but
and then that's why you use then the buoyant formula, the buoyant force, and you get the acceleration due to the forces acting in each direction.
You're not using that buoyant force. You're not.
Yes, you are. You use the buoyant force and you times it by the mass of the object, which gives you then the acceleration in the opposite direction to gravity. Like I don't know how simple I can make this for you.
After you calculate the buoyant force, you're not using this number.
Yeah, well, you're then using the result of it, which is the acceleration
mass
downwards.
Of the object.
Yeah,
you're using the mass of the object.
Yeah, and you've done that, right?
Not the force.
Right. Let me once more for the people in the back, right? And follow along to see where you get each thing from. Right. So you've got an object falling towards Earth. Okay, and it's going towards some water. You know the mass of the object. And you know the density of the object. Okay? Right, so you take the mass of the object and you use that to calculate the force created by gravity, which then you take that force, times it by the mass of the object to get the acceleration towards the ground. Right? So you've used the force of gravity to get acceleration 1. You've used it. It's there. Now we've got acceleration 1 towards the ground, which is, let's say, 9.8 meters per second squared. So you've used that. You've not thrown it away. You've used it as a variable in an equation to get an answer. Then you go to buoyancy. The force of buoyancy is rho GV, density of the object, volume of fluid displaced, and the downward acceleration due to gravity. Right? So you know the mass of the object, so you can get the force of buoyancy on the object because you know the density, which means the amount of fluid displaced. So you've got the force of buoyancy now, and you times that by the mass of the object, and then you get acceleration 2. So now I've used the second force equation for buoyancy. Now I've got acceleration 1 going this way, acceleration 2 going that way. Acceleration 1 was 9.8 meters per second squared. Let's say acceleration 2 is 11.7 meters per second squared, which means it will never go down. If acceleration 2 is 7.2 meters per second squared, you now have an overall downwards of 2 meters per second squared. You've used every single part to get to an endpoint. How do you not understand that? That's density, like 1 add 2.
Yeah, no, I agree with you. You're saying density of the object is the determining factor if the object sinks.
No, it's just
floats.
one of the variables, not the determining factor. It's one of the variables. I mentioned many variables. You wouldn't
be able to determine it without it.
Yeah, but you also wouldn't be able to determine it without some of the other variables as well.
You could definitely. You could calculate buoyancy without gravity easily.
Well, no, you need the acceleration due to gravity in the first place,
don't.
Which is not. You
really
do
don't.
Because buoyancy is rho GV.
Okay.
And G
take
in
out
that
G and rho GV that you're talking about. That's the little
you can't.
G, right? That's the little one, right?
Right. Archimedes' principle is simply FB, the force of buoyancy equals the weight of displaced fluid. That is the actual principle. The buoyant force equals the weight of the displaced fluid, right? But weight itself is a product of gravity.
It's just so they take the mass of an object and multiply
times it by the acceleration due to gravity, right? So and then if you've got the mass of the object, you can then calculate the density of it. So Archimedes did the simple part,
multiplying it,
but he didn't. Yeah, Archimedes did the simple part, but he didn't give the explanation as to why it happens, how to calculate the force of buoyancy. For that, you need, if you want to do it from the mass of the object and everything and know it in advance, then you need the acceleration due to gravity, which is part of the formula to actually get the force of buoyancy. When you have to,
you're talking about.
Yeah, because
the mass multiplied by the same number.
No, you don't multiply by the same number.
Formula without multiplying the number by a constant.
No, that's not how you get weight. That's not how you get weight. Weight is times by the acceleration due to gravity, which is about 9.8 meters per second squared. Anyway, I'm going to show you my evidence now.
That 9.8.
You've argued with me. All right, dude. I want to show you my evidence. All right, I'm going to show you how you actually show evidence. You showed no evidence, and then you've misunderstood a bunch of physics.
No.
All right. What is your educational level in physics?
What does that have to do with the?
Well, because I need to know your level of understanding. What did you do? Higher physics? Have you got an undergraduate degree, a master's? What did you get?
A piece of paper from a university has nothing to do with your intelligence.
It does to do with your expertise on a subject like physics.
It doesn't. Physics is not a hidden. It's not a secret knowledge that only universities have the ability
how do you know that you understand it if you've never taught
anybody
yourself?
To research?
Yeah, but you didn't even know that it's not P, it's rho.
What do you mean?
So
I didn't
clearly
even
don't
know
anything about
what
physics.
Didn't I know? What didn't I know?
That you didn't know that it's rho and not P, for instance. That you didn't understand that the force of buoyancy is also due to the acceleration due to gravity, and that's how you calculate it.
No, you're not understanding
weight is mass times gravity.
Same results when you're calculating buoyancy. You can get the same results without multiplying.
No, you can't.
G.
No, you can't because
the numbers
you times
will
it
come
by
out
the weight.
It'll give you the same difference in numbers.
No,
multiplying it by that 9.8 m/s squared.
No, you
that
can't.
9 meters a second squared. Objects sink at different rates.
That's to calculate that, you need the 9.8.
Right,
stop. To calculate that, you need the 9.8 meters per second squared because weight is mass. Stop talking when I'm talking. You need it because weight, which is the thing that Archimedes times it by, if you want to calculate the weight, you need to use gravity because weight is mass times gravity. The acceleration due to gravity, 9.8 meters per second squared. So you cannot calculate the force of buoyancy without using that 9.8 meters per second squared, which is due to gravity.
You're saying that you wouldn't get the same difference in results, like the difference in answers, by doing the same, calculating the same force.
If you have part of the answer already, if you have part of the answer already, if you don't know the weight of the object, you can calculate that by taking its mass and timesing it by the acceleration due to gravity. That's what weight is.
Yeah, but the weight of an object doesn't determine if it sinks or floats either.
Yes, it does. That's literally what Archimedes said.
No.
Archimedes said the force of buoyancy is due to the weight of the fluid displaced. That's what Archimedes said.
You could say the mass displaced.
No, he said weight.
It's the same thing.
No, it's not. It's not the same thing. There we go. Hold on. There we go. Hold on. It's not weight and mass are not the same thing.
I know they're not.
Right? To get weight, which is what Archimedes said, you need the mass of the object and then times that by 9.8 meters per second squared, which is the acceleration due to gravity on Earth. That's what it is.
What is the difference between using the mass of the object and using the mass of an object times the exact same number?
You're not timesing it by the same. You're not timesing it by the same number. You're timesing it by 9.8 meters per second squared.
That's what it is. That 9.8 meters a second is what you're multiplying the mass by.
Yeah, that's how you find out the weight of something.
Okay.
Right, and Archimedes said that it's the force of buoyancy is due to weight. Right.
Why couldn't you replace that with mass?
Because mass is not
results.
Mass is not weight. They're different things.
Yeah, but when you multiply it by the same number, you're going to get the same result.
No, you're not, because you have to get the weight, you have to times it by 9.8 meters per second squared.
Why do you have to multiply it by this random number? Why?
Because that's what the formula for weight is.
No, I'm saying, how would that affect the results when you're putting it?
Because it would be a different number.
Yeah, but the differences in the numbers when you compare.
Right, create a new system then that doesn't create a new system. Right, yeah, but that's because one is weight and one is mass.
Fundamentally,
so to use the formula, you have to use the correct thing, because the formula isn't just x times b, it's x times b plus c, or b times c, right? It's the mass of the weight of the object isn't the same as the mass. The weight of the object is the mass times the acceleration, right? So if you were to break it down and take away the mass, it would then be that the weight is it's just the mass times the acceleration.
Clarify the significance and importance of multiplying the mass of an object to 9.8 meters squared. Why is
so the formula works, because that's what
why
F
is that
is.
essential to calculating the correct results?
Because that's what the
Why is that
force
so
is.
essential?
That's how you calculate a force.
But why? What? No, you're not explaining. Why is that an essential part of the formula? Why do you have to multiply it by that number?
Because then no matter what the number is, you can calculate the force if you have those two variables. And they don't move up in the same amount. As one goes up, the other doesn't go up by one. There's going to be an exponential difference when you're timesing different numbers. So it's not a simple one-to-one ratio like you're imagining. To calculate the force, you need both the mass and the acceleration. And then you use the force in other things. Mass is not force. Mass is not weight. Weight is a force. And weight is mass times acceleration.
You're just taking the mass and multiplying it by a constant number.
Yes, that's how you get the answer. That's how what the unit is. That's how you calculate the thing. No. That's what the formula for weight is.
When you're putting it into the formula, when you're inputting that into the formula,
because you would then get the wrong number.
Why is it the wrong? What would be the wrong number? What would be
not the correct ratio between the numbers? Because one part of the equation would go up by a different amount of the equation because you've not used the formula.
Same.
No, it wouldn't. It wouldn't be the same. That's the thing. There would be a massive difference depending on the starting unit.
Because you didn't multiply it by 9.8 ms squared.
Yes, it would. For every one, it would be 9.8 times greater. So by the time we got to 10, it's now 980 times greater. Right. Can I do my actual evidence now? Because you gave no evidence. You just misunderstand basic maths.
I understand. Yeah, and multiplying the number by the same number is essential to getting the right number. I got you. No.
Yes, it is. If you want to do the sum properly, absolutely. Jesus fucking Christ! What the actual smeg? You didn't even pass high school physics.
Yeah, you got me.
I mean, what you're demonstrating is a pre-high school level knowledge of physics.
No, I'm demonstrating how you're throwing in a useless calculation.
It's not a different. It's not
reality.
Because you're timesing it by 9.8. That means for every one greater that it is, it will be a 9.8 times extra difference. 1 times 9.8, 2 times 9.8. So it's not going to... The actual number that you get is going to be 9.8 times bigger each time. So it's not a one-to-one ratio. You need that part of the formula to get the answer. Jesus Christ. Right, anyway, be quiet. I'm gonna give you evidence of the shape of the Earth with measurements, including water and everything that you're so desperate for. And then, if you want to speak to a PhD that uses the shape of the Earth in his job, I'm more than happy to bring them on for you as well.
Yeah, definitely.
Right, give me 2 minutes. I'll give you evidence. So, the radius of the Earth has been measured countless times, including by professionals. All these are professional measurements of the radius of the Earth throughout history by teams of geodesic surveyors, including one of my favorites, which is the triangulation of the... sorry, where is it? Sorry, it's one of these. I have to get the right one. Here we go. The transcontinental triangulation of the American arc of the parallel, which is measured across the transcontinental United States to measure the radius of the Earth based on the curvature that they measured. And here is all the details. You feel free to go through it yourself. But unless you know more than professional surveyors and people that use the shape of the Earth and measurements as their job, then this is evidence that it's been done. And the fact that it's been done multiple times, that anyone can go and check using the correct tools and methods to find out that the Earth does indeed curve at 1 degree every 69 miles. There's one of them. There's lots more. The California-Washington arc of primary triangulation. Another survey done. Anyway, there's lots of these surveys, and you feel free to go through the evidence yourself, but the fact that it's repeatedly done over and over and over by multiple different teams shows that the measurements of the Earth always actually show it to be a globe. If you want to talk about water, here's a good one. Jesse Kowalski, a surveyor, he actually used the surface of water. This is a lake that is 1 mile, and using professional methods and professional equipment, actually measured the drop from a tangent point, which is what flat earthers go on all the time, which would give you your curve over a distance. And this isn't the only one. He did this experiment a few times, and so have other people. So using his professional equipment, even mapped it all out and everything to get the calculations, and found that overall there was a drop from tangent of 8 inches per mile squared. Here you see what it says here. Results are decimal feet, and it 0.15 is 8 inches per mile squared. So when professionals measure over water, you do find a drop from tangent of 8 inches per mile squared, which is exactly what we expect. More curve of the Earth stuff. My friend Mr. Sensible sent up a weather balloon to look at the curve of the Earth. This is the kind of the money shot here. Using a non-fisheye camera. All the details of the camera are available in the description, and even put the camera up for sale. And as you can clearly see here, there is a curve. Not only is there a curve, but the curve actually matches the predictions of what we expect it to be. Compress it side to side, you can see the curve much more clearly. If you're wondering what the strings are, those that the blue and yellow string there, let me show you. This is the actual device they sent up, and as you can see here, they've got a blue and yellow string going across the front. And basically, if they stay as straight as they are for the whole flight, then whatever is in between it is also obviously straight, which is why you have the strings as a reference in the images. So this actually showed what we predicted. Where is it? Walter Bislin, someone extremely clever that makes computer models and stuff, analysed Mr. Sensible's footage, put in the overlay based on the horizon that we see. And it actually really completely matches the predictions of what we expect it to be. He even took the other cameras, which were fisheye, and put them through a conversion thing to remove the fisheye, and they also showed curves. So all 3 cameras, especially the non-fisheye one, showed that the Earth curves at the predicted amount. Rotation is a very easy one. Rotation of the Earth. You can measure it with a pendulum, like this guy did, and like this is how I've measured the rotation of the Earth myself. Very simple. What he does is he lets a big ass pendulum swing back and forward for as long as it can, and it's tracing a line through an ink pad and drawing a line on the paper. If the Earth is rotating, then we would expect a swinging pendulum like this to drift over time depending on its latitude on Earth. So basically they let it go. After 41 minutes, they measure the angle, and it's drifted from the straight line path to that. And so they measure the angle, which is I think about 17 degrees, something like that. And then they times it by Foucault's sine law, and you can use that to calculate your latitude on Earth. I've done this myself during my physics degree, so I've measured the rotation of the Earth myself and also calculated my latitude on Earth due to the rotation, 7.89. It was the degrees there, and they used Foucault's sine law, and they calculated their latitude on Earth, which is brilliant, exactly what we expect. If you want to see the Earth moving on its own, just go to many of the satellites in space, especially probes that have gone really far out, and watch the Earth move. Also, we want to talk about the solar system and stuff in general. Flat earthers always say that the stars don't move. Well, the globe and the solar system and everything moving predicts that Bernard's star, which is quite close to us, would change position noticeably over 30 years. So we measured it over 30 years, and it actually did change position exactly as we expect. This is what the globe model predicts, and there it is. There is the evidence, and it's still moving now. Anyone can measure the proper motion of Bernard's star. Here's some iPhone footage of the Earth from space, thanks to the crew on board Artemis 2. Raw iPhone footage, which they've shown and everything. So, and this is, what flat earthers always ask for. Well, why don't they take a camera up? Well, they did. Here you go. Here's a camera recording the Earth going behind the moon. And let's talk about the sun. In 1959, we used radar to measure the distance to the sun. Basically, we fired out a massive pulse at the sun. It took 1,000 seconds to come back, which gives us, we've used the speed of light, a distance of 93 million miles. This has been repeated over and over and over, and matches every other method of measurement of the distance to the sun. So there we have the curve of the Earth. There we have the rotation of the Earth. There we have real movement of stars, distance, moon on the Earth from the moon on an iPhone, and radar echoes to the sun. That is evidence, not claims. So, how do you feel about all of that?
Okay, I guess we'll start with the geodesic surveys that you provided, where they supposedly measured like the curvature of Earth and everything. Do you know what equipment those people use to measure Earth?
Total stations for the theodolites.
They use what?
Total stations and theodolites.
Total stations and theodolites. So they went all over Earth with theodolites.
Yes.
And
they
curvature.
They measured out triangles over distances, and then put those together, measured the arc length based on what it is, found out that every single triangle they measured more than 180 degrees. And as I'm sure you're aware, there's 180 degrees in a triangle, unless it's on a sphere, of course, and then it would always be more than 180 degrees. So they measure the triangles, measure the degrees, and then you can put them together and show the actual curvature of the Earth and the exact curvature rate, which happens to be 0.
Celestial navigation wasn't used for a long time.
No, celestial navigation is used all the time. I've used a sextant myself. I've got I've got an astrolabe here. I've used a sextant for like over 1,000 hours. I was a sailor in the Royal Navy. We can absolutely use celestial navigation because we chart the moving position of the stars.
That requires a triangulation, right?
No, it requires triangulation.
Yeah, you're
not triangulation, triatellation. They're different things.
Triathlation.
Triatellation. Okay. Yeah.
That doesn't work on a globe because your eyes.
It works perfectly on a globe.
Linear perspective applies to everything.
Could you
in your
explain
view.
to me the method of using a sextant?
It's you take the how high it is above the horizon to the horizon in your position to get that triangle.
No, you're not getting a triangle. You're getting an angle.
You get an angle.
Yeah, you're not. There's no triangles in celestial navigation.
Okay.
You're pointing towards the GP, not to the actual position.
The way your vision works is like you don't see in a straight line endlessly.
The stars in the sky. You just see light that's come to you.
Yeah, but the stars in the sky are definitely, linear.
These are all just claims.
Applies to those as well.
Yeah. So what's the law of perspective? Do you know?
How far your eyes can see is based on the angular resolution limit.
No, that's not how far your eyes can see. That's when your eyes can resolve an object. You can still see light coming from an object, regardless of the distance.
You can't see it.
You can still see the light coming from it. Like you can, if someone's shining a torch from miles away, but the torch is too small to see, you can still see the light from the torch, but you can't resolve the actual torch. And angular resolution doesn't work independently for different parts of an object. The bottom isn't too far away.
Endlessly forever. Light waves
yes, it does.
do get weaker.
Yeah, but what's
really?
How do you calculate the intensity of light?
In the sky, that light's going to travel all the way to space.
Michael, what do you use to calculate the intensity of light?
Lumens.
Have you heard of the inverse square law?
Yeah.
Right. Could you tell me at what point the inverse square law reduces to 0?
It would depend on the distance.
Never. Never is the answer because it's inverse squared, which means it could never reduce to 0. It just gets smaller. Light gets weaker over distance. It doesn't ever reduce to 0.
Exactly. If it gets weaker over distance, it's not traveling forever.
Yeah, it does. It just gets weaker and weaker and weaker. It doesn't ever reduce to 0. So it's always going to be there, but it gets really, really weak. Our eyes can detect as little as 2 or 3 photons hitting the sensors in our eyes, right? So that's all we need to be able to see something. And the inverse square law means that light will never reduce to 0. So it does travel forever unless it's blocked by something or absorbed and re-emitted in another form.
Objects can definitely be obscured from the viewer's view without a physical boundary between the viewer and the object.
Yeah, but they don't disappear bottom first.
That's exactly, if it's above your head, the bottom of the object would
no, the bottom's actually going to be the bottom's actually going to be closer to you than the top.
Yeah, it's going to be closer, but the angular perspective, your eyes to the angle of the top of the building compared to the bottom.
No, angular resolution can't hide the bottom first. So you're saying if you stand on your head, then it should work the opposite way.
If you stand on your head, no. If the object is still above your eyes,
but what if it's below your eyes? If it's below your eyes, if it's below your eyes,
it's above you there.
If it's below your eyes, it still goes bottom first. Everything always disappears bottom first at sea.
If it's below your eyes,
yeah. Then according to
as it goes to the horizon, it rises. And then before it disappears, because it's level with you at that point.
So but according to your logic,
your field of view,
according to your logic, if it's below your eyes moving towards the horizon, the top should disappear first. Because that would be where the angular resolution gets compressed first as it goes towards the horizon. But that it doesn't. What happens is things move towards the horizon, go above it, I'm talking. What it does is it goes towards the horizon, rises towards it, then goes above it, and then disappears bottom first, which is what we expect on a globe. That cannot be explained by perspective.
Yes, it can, because
when
it reaches the horizon...
Demonstrate that happening then.
When it reaches the horizon, that visual horizon, for one, is not
so why do things,
horizon.
Regardless of how big they are, disappear bottom first at the same distance? If it's just too small to see, the bottom doesn't disappear first. And you've seen this in countless videos that flat earthers themselves cell phone with when they show something being zoomed in but appearing in whole, not from the bottom first.
Okay. So let's say... Okay.
So just to be clear, you've ignored all my evidence.
I haven't ignored anything you said. So... as this object, this building, you're moving far away from it. The angular perspective of that is going to go, the angle is going to go down like this, right? See, it's going to go down here.
Yeah, but that doesn't make the bottom of things disappear because of angular resolution. The entire thing would disappear at the same time. Angular resolution doesn't apply to just
closer to you.
No, angular resolution does not apply to just parts of something.
Okay, no. The part that's closest to you.
No, that's not how it works.
Very far away on the horizon.
That's not how it works. That's not how it works. No. Angular resolution.
Exactly how it works.
No, angular resolution does not work like that. What's the formula for angular resolution?
You don't see.
2 times the arc 10 of g over 2r is the answer. Nowhere in that does it say the bottom disappears first. There's a mathematical formula for angular resolution and what can be resolved and how far away it is.
The part closer to you would compress faster.
No, it wouldn't.
So it does. So
what if bits aren't closer to you? What if it's exactly the same distance to you?
Yeah, well, the top of the building is going to be farther away than the base of the building if you're on the same flat level plane, correct?
What if it's not? What if the building's only 8 foot tall, which means the top would be closer to me than the bottom?
If it's only 8 feet tall, you're gonna lose the resolution of it altogether.
You'll still see it go bottom first.
Because it's 8 feet tall.
Yeah, if you zoom in with something good enough, you can watch it go bottom first. This has been done.
You know, by zooming in, you're not looking farther, right? You're not like...
Yeah, I'm talking about increasing the angular resolution until it does disappear bottom first instead of all at once.
You know, that the compression would still apply to you in the same way because the angle...
Yeah, but in this case, the top's closer than the bottom.
That angle goes
the top's
smaller,
closer
right?
than the bottom. It's 8 foot tall, which means the top is closer than the bottom.
Yeah, but the optical horizon that you see, because you don't see a geometric horizon with your eyes.
No, you see a refracted horizon. But anyway, none of my evidence was that. I didn't talk about anything going over the horizon, so this is not talking about my evidence. I talked about geodetic surveyors and the measurements that they use.
And apparently they went all over the world with theodolites across every ocean and measured the curvature.
Yes. I showed you a
sure-
list of
sure
lots
they
of
did.
measurements.
Have you ever done it?
It's been done for centuries. I'm not a
It's
surveyor.
been done. Oh, so you're just taking what they said as truth, and just
I'm referring to the
they couldn't
experts
lie.
that have done it multiple times and that people, base
you
massive
watch them do
engineering
this?
projects on. Well, no, they were done
Did you watch
centuries.
them
They've been
do-
done over centuries.
I mean, I could show you people doing the experiments.
So you're
that
going
prove- that
nutter
show the
because it
opposite
wasn't
results.
video recorded.
No, I'm not saying that. I'm saying
Right.
you're
In
present- you're
science,
saying
we
that
have
these
to
people-
refer
you're
to
sa- you're
experts
saying
because
that
not
these
everybody
people-
can. Shut up. In science, we have to refer to experts because not everybody can do everything. That would be a massive waste of resources.
No.
So
you
if
don't
someone
have
makes
to
a
be
map
able to do
based on a
everything.
particular projection of the Earth, I will trust that they have done their job correctly. Just like I'm going to trust that people paid to measure the radius of the Earth are going to do their job properly.
So you don't you just trust the experts is what you're saying, and you just
I
trust, what
trust
they
that the
said,
experts
but
have the
you won't-
ability to do their job properly.
But you
And
don't
it's been
trust
checked
anybody
multiple
else
times.
that have performed an experiment that showed the opposite.
There's been no experiments that have shown the opposite.
So if I showed you an experiment that showed the opposite, would you agree? Would you be like, damn, they were, this person,
If
I
it
watched
was
this person do the
analyzed
experiment.
correctly, I mean, what experiment? What type of experiment is it?
I mean, there's laser tests. There's all
Well,
kinds.
lasers are light, so you would need to include in the experiment the refractive condition analysis. Right?
Yeah, no, because we don't have lasers that could nail line of sight 30 miles.
Yeah, but they take into account refractive conditions.
Right. Okay.
Yeah. Because lasers are
refraction.
light, and light
refraction-
is affected by refraction. All electromagnetic
It's
waves
shit.
are affected by refraction.
Right. And refraction determines, where that horizon is in your field of view.
Refraction determines how you see everything when you're looking for a medium with refractive properties, like the atmosphere.
I mean, the distance to the horizon is purely based on your elevation.
No, that's why
'cause
the apparent horizon, sometimes you can see further, sometimes you can see closer, because refraction changes the apparent position of the horizon. The only way you could see the actual geometric horizon is if there was no atmosphere. But you can't have a refracted
So you
something
agree,
unless
you don't
there
see a geometric horizon.
you can't have a refracted horizon if there isn't a geometric horizon to refract from. Because light
Okay,
hits
but
an
you don't
object.
see-
I'm still talking. Light hits an object, travels through a medium, and comes to your eyes. So you see the light that has traveled through a medium. Simple as that. And sometimes the
Okay.
medium can change the path of the light. Anyway, but I didn't talk about refraction. That wasn't in my evidence. So are you going to address any of my evidence, or?
I am.
you haven't
so
yet.
So with the geodesic surveys, you're just taking what their word. You're just saying.
Yes,
that
I'm
you're
trusting that
assuming
the
they did it.
experts and the multiple repeats of it done by hundreds of
You
different
claim
people.
they're experts.
Yes, they are. That's what they got paid to do their
Sure
job.
they are.
Yes.
Do
Yeah.
you know these guys personally?
Yes, I knew people from the 1800s. Yes, because I top my TARDIS every night.
Right. So you're saying you're just taking the words of people that you don't know, that you never met,
It's been tested multiple
as
times.
truth,
It's been
because
tested
they
multiple times.
wrote it in a bunch of papers.
I'm saying it matches what everyone else has ever measured.
That's a wild claim.
No, it's a
Yeah,
factual
'cause
claim.
Oh, it's factual.
Yeah,
So I
every
got it, I
measurement
got it,
that
I got
every
it, I
measurement
got
that
it,
I've
I
ever
got it.
analyzed shows that the Earth is a
Your
globe.
viewpoint on the geodesic thing is you take what these people said in a paper and you just take it as
I will
truth because
trust the
they're
word of
experts.
surveyors that are doing their job. Yes.
Yes, they're experts. They couldn't have lied.
What you're doing right now is the genetic fallacy. You're attacking the source instead of looking at the evidence. Of course, if you don't believe the evidence, in science, it's your job to test it, to go and check. But I bet
Yeah.
that you've never done any tests, have you? Me, I've measured the shape and rotation of the Earth. I've measured the distance to the sun. I've been to Antarctica.
Oh, great. So could I see those measurements where you measured the curvature and the tools you used to measure that curvature all over the world?
That I used.
Yeah, you said you've done it.
I've measured the rotation and shape of the Earth, but I did it with a pendulum, just like the gentleman physicist
The
that I
pendulum.
showed you.
Oh, the pendulum thing. Yeah, that wire that the pendulum's hanging from. Did you take into account any tension that might be on it?
Yes.
When you like,
it was set up very specifically
And
to
it-
do that. Yes.
And it didn't. The tension of that rope didn't want to turn either way. It wasn't twisted at all.
They've left it to settle for many, 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 many hours beforehand.
Okay. What about the electrical forces on the pendulum?
You could do it with different
Did you take
materials
in-
and you get the same result. If it was due to electrical forces, you wouldn't.
And
Plus, there's no measurable electrical
tension.
forces. There's no.
The string that you hung it from.
Let me finish. There's no measurable electrical forces that rotate in a manner that is in proportion to the latitude you are on Earth.
Okay. If you just let the pendulum hang there and didn't let it go, is it going to start moving?
No, and we don't say that it should. We say that once it is swinging, then it drifts over time from a straight line back and forward drift, and you measure the angle, and that drift is how much the Earth has moved independently of the swinging pendulum, because the pendulum swing stays perpendicular relevant to the axis of rotation.
Suggesting that the pendulum wouldn't sway.
No, that would
left
break the
or
conservation.
right,
No, that would break the conservation of momentum.
If you let it go on the exact perfect, and it like just perfect line, and it was weighted just perfectly.
Yes.
Because the weight, because it's not like the electromagnetic forces, or how heavy is the pendulum that you're swinging? Is it heavy enough to even maintain a straight?
It did it for 43 minutes.
And there's no tension at all on the rope.
No, they've let it stand. That's how you set up. When you set up the experiment, you let it rest for a long time before then starting it to swing. Yeah.
And that somehow gets rid of any circular tension from the rope that it's hanging from.
Yes, that when it's got no tension because it's been resting for a long time. Yeah, that happens.
It's just it would perfectly swing straight back and forth. And
yes, that's why when you do the experiment,
only reason that it could is if Earth was moving.
Yeah, and that's why, depending on where you do it on Earth, it drifts a different amount depending on your latitude, as predicted by the globe.
Wild. And does it keep swinging forever?
No, because we don't say it should.
No. Didn't say it should.
No.
So
it's clear you have no clue about physics. You know this, that you are literally clueless about physics.
I didn't know the formula for gravity or density or any of that.
Or that P,
clueless.
it wasn't P, it was rho. That was fun.
Yeah.
You realize that that's going to be a short on my channel, right?
You can, that could clip it.
I've got an assistant for that, yeah. Well, I say assistant, I mean captive held in the basement that I feed every now and then, but,
That's great.
Yeah.
I
know RachBot, it really does, doesn't it?
So, you calculated the speed of the rotation.
Yeah, 0.0000694 RPM.
When did you observe Earth, any place on Earth go from point A to point B over a certain amount of time?
I measured it indirectly.
So
because I'm on the thing that's moving. I've never been to space and been in an orbit, no.
You've never seen something on Earth go from point A to point B over a time?
I've seen a pendulum drift from angle A to angle B.
You can't measure speed. It's not how speed's measured, is by what you don't measure the speed.
Yeah,
of the
it
ground
is. I've got how much it's
pendulum.
moved. If I know the radius of Earth, because that's been measured, and with that angle, I can then calculate the distance moved and therefore speed.
Seem well educated. Do you know the formula for speed and how you calculate speed?
Linear speed or rotational speed?
I'm talking about speed.
Yeah,
Just
linear speed or
general.
rotational speed.
It's distance over time.
Yeah, that's linear speed. So how do you calculate rotational speed?
Any speed.
Yeah. How
requires
it's different, by the way.
Over time.
Yeah. How do you calculate what do you do to calculate rotational speed?
Revolutions. How many revolutions it does in a certain amount of time.
Yeah. So how would you measure that if you've got the amount is moved from an angle over time?
You're comparing revolutions to an angle?
Yeah, because if you've got the angle that something's moved, and in a circle that's 360 degrees, you can see how much of a circle it's moved in a certain amount of time, which means you could calculate the speed of its rotation based on that.
You're not observing it make a revolution.
No, you're observing it make a
the
part.
angle of a
You're
different
observing
object.
it make part of a revolution.
You're not even observing Earth. You're observing a different object.
Yeah, because
The
I'm
angle
on
of a
Earth.
different object moving.
Because I'm on Earth, so I can only view it from Earth's point of frame, can't I? Point of reference. How am I going to view it? How am I going to view it independently of Earth? I cannot
You're not watching
float.
Earth
I cannot
rotate
float,
at all.
and I'm on the thing that's rotating, and I'm watching
you're
something
not.
else move because of that rotation. It's what we
You're on the
predict
thing.
to happen.
You're on the thing that's not moving.
No, I've
you're
measured that it is
observing-
moving. There's no reason why that pendulum would drift the way it does, different amount
There's a
depending
ton
on
of
your
reasons
latitude.
Why the pendulum would drift? That's
No, there's none.
wild. There's absolutely no reason.
No,
That
there's
the pendulum would drift.
there's no measurable or detectable reason that the pendulum would drift the way it does if the Earth isn't rotating.
That's a wild claim.
Well, could you give evidence
And,
of a way?
You're entitled to that belief.
Well, give
I'd argue that
evidence of
there
it.
are a ton of
Present one, then.
reasons. Just the electromagnetic forces around the object.
Is
Don't
there?
think like
Could you present measurements of the electromagnetic forces that would make it drift proportional to your latitude on Earth?
The string you're hanging it from has tension on it.
And how would the string make it drift an amount that is proportional to your latitude on Earth?
How is it? Do you have any evidence that it's drifting proportionate to your latitude on Earth?
Yes, every one that's been done. I done mine in Bristol and used the latitude calculated to figure out where I was on Earth. It's different. If you're at the poles, it rotates a whole circle in 24 hours. At the equator, it doesn't do it at all because there's no Coriolis force at the equator. And every time the experiment's done at different places, you get depending on where you are, you get a proportional drift depending on your latitude. That's the entire point
And every time you've
result
done
of
it
the
at the
experiment.
same place.
I've done it in multiple
at the same
places.
place multiple times and got the same exact angle every single time.
I've done it in
that
different
place.
places, and I've seen other people
But you
do
haven't
it in
done
different
it
places.
twice in the same place?
Yeah, I've done it multiple times in the same place.
Could I see that evidence?
Well, no, I didn't record my personal thing from 21 years ago when I was at
So
university.
you're there you go again. You're saying you did something.
Yeah, but
you don't have any
I've just
evidence of it.
shown the same thing
You're
being
just making
done.
claims.
No, I've just
You're
shown the
making claims.
evidence of the experiment.
You haven't shown me. Okay,
I don't
so you're
have to
saying
show
that
you
if
what
you-
I
if
done
you drop the
personally.
pendulum-
I didn't say here's a video of me doing it personally. I say here's a video demonstrating the same thing that I did, and I did it during my degree over 20 years ago. Those aren't
Yes,
recorded.
but you're suggesting that if you drop the same pendulum in the same place, that it'll make the same angles based on your location.
Yeah,
That if you repeat-
all
that if you repeat
37
that
people
same
on my
drop,
course. All 37
it would
people
do
on my
the
course.
same exact
yeah.
angles every single time.
Yeah,
and
all
that's
37
all
people-
that's all dependent upon
Yeah.
your location on Earth,
Yes.
and that two different locations.
This
should
isn't
always
news.
have a
This
different
has
angle.
been done thousands of times.
Really, I know I've never seen it done.
I'm not
if you
surprised.
if you did
It doesn't
drop
seem
the
like you've
same
done any
pendulum in the
research.
same place, you'd get different angles.
They're in
occasionally.
museums all over the world because they do exactly the opposite of that.
If you started the same pendulum drop in the same place, you would not get the same exact angles every time you drop.
You
that pendulum.
literally do. This the Chicago Science Museum where I went last
Then
year.
show me.
Right. Well, I can show you a video of the Chicago Science Museum. Any video of any Foucault's pendulum in a museum around the world.
Where they just repeatedly drop it and does the same
Yeah.
exact.
Like, why do you think they've got one in the Chicago Science Museum that does the same
They don't have
thing
any
every day?
magnets under those.
No, not the one at the Chicago Science Museum. No.
There's no magnets under those.
No, not the one at Chicago. It started
Sure.
every morning and it goes, well, I was there like 2 PM and it was still going. Still measuring the same angle every hour.
Mm-hmm.
This isn't news. I don't have to prove to you that an experiment that is well known is done and with the same result.
you can't prove it.
I can show you it done. There's probably thousands of videos of it on YouTube.
Are people dropping a pendulum in the same exact place and getting the
Yes,
same exact
like
angles
nearly
every
every
single time
science
they
museum
drop
that
it?
has one will have their videos of it. There's live streams of just pendulums that are on constantly for ASMR. For fuck's sake.
So you got no evidence of that. Gotcha.
Every
So
single
pendulum
science
can't
museum
be
in the
any-
world is my evidence. The video
So
I
there can't
showed you
be-
is my evidence.
Yeah, science museums can set up a display with a pendulum.
It's an
for
experiment.
people to walk in and look at. It's not.
If you doubt it, then do it yourself. Your denial
Okay,
is not.
watching a
Your
pendulum
denial of
watching a
evidence is
pendulum
not a
swing-
rebuttal of it.
You can't measure the speed of the ground
Yes, you can.
moving. Watching a pendulum swing.
I did.
No, if you want to measure the speed of something, you have to observe it go a distance over time.
I did. I
If you're
observed it
not-
go from angle A to angle B over time.
You watched a different object go different angles.
No, I watched the
That's
ground.
not- it has no
from my
relation to
perspective, I watched the ground do
you're
it.
standing on. It's the same way.
If you're on the
that
thing that's moving,
you try to
you have
measure
to do it from
the
that
shape of the
reference
Earth by
frame.
looking at something in the sky.
It's not on the
It's
sky;
like-
it's on the ground.
No, I'm saying it's the same. It's the same angle they use for the fantastic experiment where they were trying to look at something in the sky to prove the shape of the Earth, and that's the
It's
the
evidence of the
desperation
shape
that
of the
they've had to
Earth.
cling to.
It's a great way to show what the shape of the Earth is, and just because you don't understand it, of course.
It was a great 24-hour.
You sure you've been
live
doing
stream
this
they
for
had,
10
too,
years?
That didn't happen. Yeah. Yeah.
You
I
seem
have.
like a baby Flerf.
I'm a baby Flerf.
You seem like a very baby Flerf. This is all like I've been doing this for nearly
You going
7
to name
years, and this is
calling?
like day one.
I mean, really already with the name calling?
No, that's not name calling. It's a classification. We have classifications of Flerfs, like
calling.
Papa Flerfs, Parrot Flerfs, NPC Flerfs. You're what we would refer to as a baby Flerf. It's not a name call;
calling.
it's a description.
That's a really
You are a Flerf,
great way to.
and you seem like a baby in the sense that you don't know much about the concept of the flat Earth.
Huh. And you came to this assumption because.
Because I've spoken to nearly 2,000 flat earthers.
Uh-huh.
Yeah, and
And,
I've heard all of
and-
the arguments
and
that you're
apparently-
saying over and over and over, but it's usually from the ones that have not
I have
been
no
doing it
idea
for
what
very
I'm
long.
talking about when I've addressed every single one of your points.
You haven't addressed any of them. You've misunderstood them.
No,
Like not
I've
understanding
understood
how
them.
you calculate two different accelerations going against each other to do a summation.
No,
of,
I
of
pick
the...
up what you're trying to put down.
No, you don't.
No, there's no. Trust me, there's
No,
no
you don't, Mr.
misunderstanding.
Rho is P.
I'm not.
Right, so you don't understand the fact that the pendulum does exactly what the globe predicts, and that's what you do. Science, you make a prediction and you test it. But science, you've never done it once in your life, so.
I got it. Yeah, no, you're trying to measure. You're saying that you're measuring the speed of something by looking at the angle of a completely different object moving.
Yeah, if
Gotcha.
you're going to deny it just because
Gotcha.
you don't like how you can actually measure things based on relative motion, that's
No, I
kind of your
understand
problem.
how speed is measured.
Yeah, and you can calculate speed by the way that I've described.
This is well known.
Yeah,
I mean, you observe it move a distance over time.
yeah, and I did
That's
that.
how speed. That's how you measure. No, you didn't observe Earth moving any distance.
Yeah, I did. Earth went from point A to point B
Earth
as
didn't
the
move.
pendulum
You
swung
weren't even
above
looking
it.
at Earth.
Yeah,
You're
I was.
not
I was.
even looking
I was
at-
watching the ground.
You're watching a pendulum.
No, I looked at the ground.
The Earth didn't move.
Yeah, I watched it move as the angle changed with the thing swinging in a straight path above it.
No, the Earth was in the same place, and you know what was moving was the pendulum. The pendulum was moving.
Well, relative
The
to the
Earth-
Earth, relative to the Earth, the pendulum was moving. But relative to the pendulum, the Earth was moving.
Yeah, relative to everything.
Relative to the
Like the Earth, like
relative
Earth,
to the pendulum,
Earth is what is what
relative
you
to the
relate
pendulum,
speed
the Earth
because
was
the
moving.
Earth is the
Shut up
constant
and listen. Relative to the
thing that never
pendulum,
moves.
shush. Relative to the pendulum, the Earth was moving. Because in science, you can choose anything as a rest frame.
Yeah, you could, but that doesn't give it speed.
Greater Sapien, a great dude in the chat for $20 says, bruh, I can't anymore. It's like this dude is trying to fake his way through an oral report on a book he didn't read. Guys, don't forget, if you want super chats read out, either be funny like Greater Sapien or ask a question, and we'll see if we can get Michael to answer some questions once he's addressed my evidence and had we chat with PhD Tony if Tony's still there. Right, so you don't understand that. The fact that I sent up weather balloon, well, Mr. Sensible sent up a weather balloon, and it was analysed, showed exactly what we see. The real movement of Barnard's star, the Earth from the iPhone with the moon the Earth going behind the moon, the radar echoes from the sun showing that the sun's 93 million miles away. Are you just going to nut all of these?
No, well, I love the picture that they took on Artemis, where it was, they took a picture of the moon and they had like the sun. It was like eclipsing the sun.
Yeah.
But when you put in the measurements for like how far away they were supposedly from the moon and what the angular size of the sun should be at that distance from that side of the moon, like it would definitely not make an eclipse.
Could you show that
around the moon
evidence,
because-
please? That's a lovely claim. Can you present that evidence?
Yeah, I guess I'll have to find the. Let's see.
And did they take
Artemis
into account the
to-
crop of the picture, the
That's
angle
what
of the
it-
phone, the lens used, everything,
Let's
Hey, Toon, how you doing?
lunar flyby.
Just run us through the math, bud.
Right here. Let's see. Yeah,
And put the source in the chat of the Zoom call.
oh, it's the NASA website.
Oh, so NASA are saying the picture's wrong, are they?
No, I'm giving you the image that they provided and how it definitely shouldn't have looked.
Well,
according
I
to
want to see the math to
according
show
Helios,
that it shouldn't have looked like that.
Okay. Well, let's see. I'll put it in the chat so you just click the link, I guess, and show it.
Yeah. Yeah. So this is the math showing. Wait, not the chat of the live stream. You can't put links in that. Put it in the chat of the Zoom call that we're in.
Oh, okay.
So just to be clear, you're going to give us the math that shows that picture that NASA provided is wrong. Because all you've done so far is
Well, you can
make a
calculate the
claim.
angular, like how big the angular size of the sun would
Yeah,
be.
yeah, which is
from
what
that
you need to
distance.
do. So you need to give us the math to back up your claim.
See, where's the chat? Oh, there it is. There's the picture.
Right, so that's the NASA image. So now can we see the math to back up the claim that that's incorrect, please?
All right, so let's see. Where does it say how far away was that picture taken from?
Talk us through the math.
It
Come
should
on.
have
What's the math?
Well, I'm gonna have to put. Apparently, I'm gonna have to put all this together because.
What are you saying? It's
Let's
not
see.
been done?
No, it has.
Well, just link us to
Truly
the
block
source then
sun,
of
54 minutes,
of
see
it.
glowing halo around. Okay, they didn't put the distance in here.
Yeah, but you said that the math's already been done, so just show us where the math's already been done. You don't need to redo it. And how would you calculate what the angular size of the sun should be from there? What's the formula for angular resolution or for angular size?
Let's see.
Michael, what's the formula for angular size?
I don't have it on hand.
Well, you don't know it? You said the maths is wrong and you don't know the formula for angular size? It's alpha equals 2 times the arc tan of g over 2r.
No, I'm talking about how big the sun should appear from that distance on the opposite side of the moon.
Yeah, but you to be able to
You're
calculate
4,000
that, you need
miles
to
off the
know
surface.
to calculate that, you need to know the angular size formula. So what is the formula to calculate the angular size of something based on distance?
Like I said, I don't have the formula on hand. I'd have to.
But why don't you
I'd
know
have
it?
to find it again. What do you mean, why don't I know it? I don't know the distance of the where they claim to take the picture.
Yeah, what would you
from
do with the
moon.
distance?
To figure out the angular size?
Yeah.
You'd have to use the size of the sun and the distance.
Yeah, and what would you do with them?
What would I do? With
How
them? To
do you
figure out
calculate the
size?
angular size? So you've got the size of the sun and the distance to it. How do you calculate the angular size?
Same way you calculate any angular size.
Which is what? What's the formula for that?
It's just calculate the angle from the viewer's eyes to the object.
No,
How
that's
big
the
it should
angle, not
appear.
the angular size of something.
Yeah, the angular size. How many?
So what
degrees
is
it's
the
gonna take up in
formula
in
to
your field of view?
calculate angular size? Alpha. The formula is alpha equals 2 times the arc tan of g over 2r. That's how
Okay.
you calculate how big something should appear based on how far away it is.
Yeah. And
why didn't you know that?
Why wouldn't? Because I don't know the distance.
Well, yeah, but you didn't know what to do with the distance. You could give me an angle, but that's just an angle.
No, I said I'd have to calculate the angular size.
Yeah, but you didn't know how to do that.
Because I don't know the distance.
Yeah, but even if you had the distance, you wouldn't know how to do it.
If I had the distance on the other side of the moon, then I could use that distance with it's just the AU, which is the fucking the distance they claim Earth is from the sun. Add the distance from the Earth or from the moon.
No, I've just told you how to do it. Are you not listening to me? To calculate the angular size of something, you do alpha equals 2 times the arctan of G over 2R. That's how you do it, not whatever you're talking about.
Yeah, but you need the distance, right?
Yes, and then distance is part. That's what R is.
I don't have the distance. What I'm saying is I don't have the distance.
Right. Well, how do you know that it's been done then? You said it's been done.
I've seen the formula before. I've seen it calculated before.
Where?
I just didn't have it on hand.
So you got no evidence of that claim?
It's the same as you claiming. You see, same as you in the papers you showed.
No, I've got all the figures in the paper that can be checked against reality. You've not even got the figures
that can be checked. You don't have any of the. You just take, like I said, you're just taking the words of what they said, and I'm taking the.
No, I'm taking the word of it being done hundreds of times and getting the same answer.
You have any evidence of people doing this hundreds of times?
Yes, the list I showed you.
You showed papers.
I showed the list of the papers of the results of them doing the measurements. You write down the measurements.
Yes, you showed a list of papers.
Yes, that's the measurements.
Which is, okay, that you believe that they did.
Yeah, and then other people did them, and then other people did them, and then other people did them, and then they're checked today when surveyors do their job today. Tony, I've sent you the link, by the way. My head's about to explode.
You're claiming this.
Yes, because it matches the other things that I showed you, like measuring the curvature of water and the drop from tangent being 8 inches per mile squared. It matches every time you do the measurements. It shows the same thing.
Really?
Yes.
I haven't, but have you done the measurements? Have you done it yourself?
I used the Foucault's pendulum to calculate the shape of the Earth based on the mathematical principles of it being a certain proportionality between the angle of drift.
You watched the pendulum swing.
Yes, and then I calculated the shape of the Earth with it.
I
used that to calculate the radius of the Earth.
Earth.
Yes, and then I used all the details to calculate the radius of the Earth. Yes, I've also measured gravity and the distance to the sun, and I've been to Antarctica. Don't judge me by your low standards.
I mean, measuring an explanation is pretty wild.
No, I've measured the force created by gravity.
You measured it?
Yes.
They gave you the formula for it. You should be able to calculate it, but actually measuring it and
I actually measured it. I calculated how the attractive force between objects based on how much certain things moved. I did the Cavendish experiment.
Oh, the Cavendish experiment.
Yeah.
Okay. Yeah. So, even when two objects of the same gravitational force sink and float.
I've explained that to you. I even talked you through the maths.
Because you have to add in, you can't figure it out without figuring out the density of it, right?
Yeah, you've reset. I've been through this with you.
Kind of useless to calculate the force of an object.
No, the force is one of the variables in the equation.
It sinks or floats. It's not one of the forces. You don't use it after the density.
Yeah, you do to get the acceleration. I talked you through where you use it. Do you have, problems converting short-term to long-term memory? Maybe you shouldn't smoke weed.
If you can't figure out the whole thing without the second part of it.
You can. That's the point.
Really? Yeah, the second part of it is the entire equation. Because when you're comparing that to the same
Tony, I've sent you a link.
Using,
come and save me, please, mate.
You're using the different densities and the same force. What's the determining factor?
That you need to get the weight, which is the force. It's not. There's a difference of 9.8 each time.
Forces could be the same.
But they're not the same. To calculate it, you have to. Oh my God, I'm not going back through the same thing.
Using the mass to calculate the force.
Yes.
Yes. Two objects of the same mass with different densities. One's going to sink and one's going to float, but they have the same mass.
Yeah, because of the buoyant force. We went through this. The buoyant force is different because of the density.
Yes.
But that's a result of gravity also.
Buoyant force relies upon density. You have to calculate the density of it.
Yeah, and the density displaces a certain
But the
weight of
gravitational
fluid.
force could be the same.
We went through this. You then use that to calculate the amount of the weight of the water or the fluid displaced.
Yeah, you're
So
using,
weight, you
so
still
both-
need to use gravity in. For fuck's sake, we went through this.
Use
I'm not going
mass
through it
and
again.
Newton's
I'm not
formula.
going through it. Yeah,
Use-
one sec.
use
Yes,
mass and
Tony, I
Newton's
sent it
formula.
via Discord.
Yeah, you send mass. Use mass in Newton's formula, and two objects of the
Yes.
same mass
We went through this. I
can
explained it
sink
to
and
you.
float. Yeah.
Yes, that gives
I
you the
know.
acceleration downwards. And then you have to calculate the acceleration upwards due to buoyancy, which you use the density for. And if the
Exactly.
density is higher or lower, and so it's more volume, then it displaces more of a weight of fluid. And to calculate the weight of the fluid, you still need to use gravity.
That force that you
All right, shut
calculated
up.
with the same
We've been through this. We're not
1,000
going around in
They
circles.
both weigh 1,000 grams. They'll have the same force.
And yes,
Why,
so
but you're not,
when
but
they're
you're not gonna
outside
figure
of
out
the
if it
water,
floats or sinks.
listen, so when they're outside of the water, they're going down at the same rate. But when they're in the water, they will have a different buoyancy, which means that there will be a different force in the opposite direction.
They
We
have
went
different
through
buoyancy
this.
in the air as well. Well, you think like you're not surrounded by fluid?
Yeah, that's why there's such thing as air resistance. But in general, it's very little.
That's why you don't float away, because your body is denser than the surrounding fluid,
You don't,
and
yeah,
everything sort of
because
falls into
you
place.
don't
in
float
our
away because of
electromagnetic
gravity.
Field.
There's no electromagnetic field that we can measure down
It's-
here like that.
Yeah, no, the downward force is actually caused by incoherent dielectric acceleration.
All right, Witsit. No, it isn't. I've already destroyed Witsit on that. That downward 9.8 meters per second that you would apparently get from that
Measurable 100
actually
mils.
dissipates after about 300 meters.
You know, like, there's a lot of oxygen
Right,
around
hold
sea
on.
level.
PhD
right?
Tony
we get
isn't
most of
getting the
our
link to
oxygen from the
join.
ocean. When there's a
Oh.
lot more gas, like the denser gases, electrons don't pass through them as freely.
Yeah, they do.
The more oxygen an electron has to pass through,
Yeah,
the less conductive it is. That's why the closer you get to the ground is electrically neutral. You know, there's like
the ground, the entire
Right.
Earth is electrically neutral, but the ground is actually slightly negative.
gravity.
Yeah.
You know,
Right.
gravity
So
is-
now be quiet because I'm going to introduce someone actually a lot smarter than both of us. This is PhD Tony. Tony is he's obviously got a PhD, hence the name. He has measured the shape and weight of the Earth, uses gravity in his job, knows everything about earthquakes. Tony, please help me introduce yourself to this guy. Welcome, by the way. Thank you.
Hi, Tony.
You're muted, Tony. Let me. There we go.
Okay. Hi. I'm Tony. Nice to meet you. Your claim is that objects fall because of the contrast between densities.
No, objects sink. You know, whether an object sinks or floats is going to be dependent on its density in the fluid it's in, compared to the fluid it's surrounding it.
So if I have two objects and I control their densities, so I have one object with a known density, I have a fluid and I control its density, then the object should fall through that fluid or should sink through that fluid at the same rate all the time, right? Because it's just a function of the two densities, right?
Well, there's also the buoyant force. Once it gets deep enough, it'll have more buoyant force pushing down on it at a certain point.
Buoyant
because
force
there's more-
doesn't push down. You don't know what you're talking about.
So
Let me
submarine
repeat.
just
Let me
gets
let me
crushed by
repeat.
water.
Let me repeat the question. Buoyant force does not push downwards. Buoyant force is always an upwards force. The fact that you look confused like a troglodyte doesn't make what I'm claiming. Would you like to go through how we actually derive buoyant force? Is that the level that we need to pitch this at?
Yes, this one's exceptionally dumb, Tony.
Okay, do you know how buoyant force is derived?
Yeah,
He doesn't.
Okay, yeah, please explain.
it's you could do it without gravity. You're saying
No, you can't.
Yeah. Okay. So you can't take the amount of fluid displaced and the mass of the object.
The weight of the fluid.
Without
That isn't a
multiplying it by g.
derivation. That isn't a derivation of buoyancy. That's a description of buoyancy. You are not showing us. You are not showing
the buoyant
how the
force?
result is. You are not showing how the result is derived, which is what I asked for. I asked you, how do you derive that formula?
I'm going to grab a quick.
How do you get there? How do you know that that's true? Why is that true?
What do you mean, why is that true? Calculate the buoyant force?
Yes.
Take the mass of an object.
How do you obtain? How is that formula obtained?
You take the mass of the object.
That's my question is not what is the
you're
formula.
not letting me. I mean, you're not letting me finish.
You are, but I know what you're saying. You're just giving me the formula again. That wasn't my question. My question is, okay, how do you derive the formula? Where does the formula come from? You know the formula for buoyancy. Where does that formula come from? How was it obtained?
Archimedes did it first.
Archimedes
gravity.
Archimedes noticed it as a law. He didn't derive the formula for it.
So Archimedes didn't figure out buoyancy.
I just
long
said he
before Newton
figured.
was
I
born.
just said he figured out the law. I didn't say what and what
Was he
I asked
calculating buoyancy or no?
for. He
was he
was
calculating
not.
buoyant
He
force?
did not. He did not calculate. He did not go through the formula derivation of the calculation. But regardless, you have managed to sidetrack the conversation again. I asked you if we have a medium whose density is controlled and an object whose density is known, does the object always fall through the medium at the same rate?
It would depend if the density of the object, what the density of the object.
The density of
compared to
the object
fluid
is the same. The density of the medium is the same. Please listen to what I'm saying because that was part of the question. The density of the object does not change. The density of the medium does not change. Therefore, if your theory is correct, if your hypothesis is correct, the object must fall through the medium at the same rate every time. Correct?
Yeah, why wouldn't it do that?
Because it doesn't when we measure it.
And when have you taken an object, the same object, and dropped it in the same fluid, and watched it just sink at wildly different rates?
Every time we use a gravimeter, a drop gravimeter. So in a drop gravimeter, do you want me to show you a picture of a drop gravimeter?
Sure.
Just give me a second.
Yeah, it's not science unless it was recorded, Tony. Doesn't matter that this thing has been done over centuries. It wasn't videoed with a GoPro, therefore it didn't happen. I'm paraphrasing.
Didn't say that. I just pointed out that
You basically
you
did.
believed claims that you read in a paper. That's okay.
We'll get there, Max. We'll go through questions to the Flerf near the end. And once again, guys, if you've got a question for our quite clearly baby Flerf here, feel free to super chat or tag me
Name calling
on
again.
Discord or
That's what
something.
Says you lost a debate, like just going straight to name calling.
It's not name calling; it's a description.
It's name
It's
calling.
a description we
Name calling.
have for you guys. I'm not calling you a name.
Yeah.
It's just how we describe you're in this particular category.
Yeah, yeah. It's tough facing facts. I understand.
You haven't presented any facts. You've said a bunch of things that have been instantly disproven. You've shown no
And you
evidence. You've
measured the
misunderstood
speed of
science.
Earth
You called row P.
Looking at a
Dude, you called row P. Shut the fuck up.
Oh man, it's tough.
Right, in the chat,
like-
let's do a vote.
So, do you know where Dunning and Kruger? Have you ever heard of Dunning Kruger?
I've heard of it.
Right. Do you know where it comes from? Do you know what event inspired them to
Come up with the term.
No, I know I know you know where. So Dunning and Kruger did a study. What event inspired them to do the study? Why did they take an interest in this?
Why do you assume this applies to me?
It applies to everybody.
Because it exactly does. So what introduced
Because
them?
it exactly does.
Yes.
Because it
so-
exactly does. That's why.
Everyone can be
Yes.
measured on the Dunning-Kruger scale. So
Got
it
me
definitely
there.
applies to you.
So
You got me.
Yes,
President's actually
and
dead.
this was exactly
That's
that
why.
point. So allow me to tell you the story. A guy by the name of Wheeler MacArthur decided to rob some banks. But rather than wear a mask, he decided that he would smear lemon juice on his face. Because lemon juice is invisible ink, right? Therefore, smearing lemon juice on his face, he reasoned, would make his face invisible to cameras. He decided that he shouldn't just rely on his intuition on this, he should do some experiments. So he smeared his face in lemon juice, and he couldn't see his face. His face wasn't clear when he looked in the mirror for some reason. Okay, that's evidence. Then he decided that he would take a photograph of his face with an instant camera. And for whatever reason, perhaps because there was lemon juice in his eyes and he couldn't see where he was pointing the camera, perhaps because the film in the camera was old, whatever the reason, he came up with a blank photo. So he decided that his theory was right. So he did the bank robbery, and he stopped, looked straight into a security camera and smiled. A smug, self-confident smile about how clever he was, how much cleverer he was than everybody else in the world. And then he walked out of the bank. And he was absolutely amazed when a couple of hours later, the police showed up on his doorstep, knowing his name, and arrested him. And Dunning and Kruger read this story, and they thought to themselves, how the hell is it that someone who is that ignorant, who is that unable to intellectually process information, has so much confidence in their own ability? How is it that somebody who is so smug, who is so condescending to others, who is so sensitive to aspersions on their intellect, how is that person so catastrophically wrong? And that's what inspired Dunning and Kruger to do their study. And if you cannot see how this relates to you and your confidence in your position, then I can't help you. But we're going to get on to gravimetry papers.
I never put any lemon juice on my face.
r/bush.
No, but you're doing something that is even more stupid. That guy didn't think the Earth was flat. So compared to him, you're worse.
You are metaphorically covering your face in lemon juice live on camera.
I'm not metaphorically covering my face in anything.
He at least did his own experiments. What experiments have you done?
It was an insane comparison.
No,
what experiments have you
done?
done?
He's done none.
You're asking me what experiments I've done after you've shown me no experiments.
I've shown you a bunch of experiments, but he's just asking you a question.
So you can make claims, but I have to show experiments.
But I'll get on to... But since you asked, let's get on to the actual instruments that we use.
He hasn't done any experiments. I did ask him that.
Yeah, it finds its level.
He thinks that's an experiment, Tony.
And do you think and what do you think that proved? What do you think that proved?
I'm observing water finding its level and requiring a container because it doesn't stick to the outside of it.
You know the word level means curved on Earth, right?
Would you like illustrations?
No, it doesn't. Level does not mean curved.
Yes, it does.
And you are stupid enough to smoke.
Yes,
which tells me a lot about you as well.
Big part of a person's intelligence.
Yes.
Yeah,
yes,
it really is.
It's a big sign of how intelligent someone is.
Yeah, it is. I know. I'll give myself cancer. That sounds fucking smart.
Okay, so
throughout history, smart people have never smoked. I got it. Only the real.
It's just that you're stupid enough.
Smoked in their life.
Smart people acknowledge that it will kill them. You're stupid enough to believe that it won't.
Your IQ is relative to your habits. Okay.
Yeah, there we go.
I'm sharing.
Wild claims.
Okay.
Yeah.
So this is an absolute gravimeter. This is an FG5X Lacoste. This is the most precise gravimeter that you can find. So let's go down into the diagrams of the interior. This is what's inside it. This is what will be in the inside of the drop chamber. So this
Is that
going back
the
up
object
to
you drop in the water and watch it sink at different rates?
air is a fluid, isn't it?
Yeah,
Yes, so we're dropping it through air.
you're dropping it through air. Okay.
Yes, air's a
And-
fluid, right?
and-
you said
and it's-
you said
has the
all I
same
had to
density.
do was drop it through a fluid.
Yeah, and it's the same density.
Yes, and
Are
so
you calculating-
we control the temperature and pressure conditions inside the instrument
You can control
using
how fast it sinks and floats. Yeah.
we're not interested in floating. Why would we want to see it float?
I mean, you're saying that if you drop the same
Your
object
claim
in the same fluid-
was that if the density of the test mass and the density of the fluid were the same, then the test mass would fall at the same rate always. I'm proving
that's
I'm
also
proving
dependent
that
on
we
your
now have an
elevation.
instrument. We now have an instrument that can test this hypothesis. We can control the temperature and the pressure inside the instrument, so we can control the density of the air and we can control the density of the test mass, right? So those two things are the same. So we can control those and we can make them the same regardless of where the instrument is. Okay, this is what this ion pump down here is. It's to pump air out so that we can control the pressure inside. Ideally, we pump as much air out as we can, but we standardize the pressure. So we keep the pressure and the temperature constant inside. So this is the experiment that your hypothesis, if your hypothesis were correct, then this would be absolute proof. Regardless of where you were on Earth, regardless of where you were on Earth, regardless of the time you did the experiment, you would always get the same results, right?
I think where you are on Earth would have an effect on it. If you're
Why?
like way high up, if you're high up in elevation, it's
Why?
gonna affect. Because, what do you mean? Why? You have different air
Because
pressure, different
the
elevation.
chamber is sealed. The air pressure inside the chamber is independent of the air pressure outside of it. Why would taking the instrument high affect conditions inside the chamber?
When did you drop the same density object through the same air and see it sink at two different rates?
All the time.
All the time. Could you
yes.
show me
Yep,
when
absolutely.
you did that?
Wait, no. Our claim was if it's different densities, it would sink at different rates. Not if it's the same.
No.
densities.
No, it's fine because he's ignoring tidal variations. The rate at which objects fall is not constant through time, because there are different tidal influences on.
But you said that there's no
gravimeters.
outside influences on the
You
inside
might
of the
want to
chamber.
shut up and actually listen to what's being said for a second. I'm talking to Craig. You have no part in this exchange.
All right, but
So time. So because of time, is Abramovich there? No, it's in the gravity papers.
Do you think you can also explain to him why you need to have the 9.8 meters per second squared when you're calculating weight? Because I don't understand how I couldn't get that through to him.
yeah, no,
Yeah, we're going
multiplying by the
fairly.
same number to get the same number. Yeah, I got you.
But you're getting a different number
To
because
get what same number? What are you even talking about?
Mike, what are you talking about?
Okay, so we're going to stop that share and we're going to start up another share. Okay. Okay, so here's a set of gravity measurements through time for see how it same location on Earth. See how it varies.
Yeah, the electromagnetic field's always moving around us. Yeah.
Yeah, except that it can't be due to electromagnetism, can it? Because neutrons are observed to fall under gravity, but neutrons have never been observed to be deflected by an electrical field.
Neutrons can't be observed to fall under gravity because gravity
Yes, they
doesn't
can.
exist.
Yes, well, neutrons are observed to fall,
Well, yeah,
but
I mean,
neutrons cannot have not ever been observed to be deflected by an electrical field.
Because they're
when
neutrons,
have you
which
ever
means they're
seen
neutral.
neutrons
So
outside of where gravity was supposedly acting.
What are you even talking about?
You're suggesting that the neutrons are acting a certain way under a theory, okay, as opposed to neutrons
gravity's not a theory.
and how they
Be
act
clear about that.
So have your
outside
claim
of gravity.
No. Your claim was that the reason gravity varies through time, and
I
I'll
didn't say
note
gravity
here,
varies
if
through
you
time.
look
I said
closely,
gravity doesn't exist. I
if
don't
you
believe
look
gravity
closely,
exists.
Because
and
you're
this
fucking
is
retarded.
this is why you and this is why sort of this is why the Dunning-Kruger applies to you
No, it
more than it
doesn't.
does to anyone to
Oh,
anyone
because it
else.
has to. Because you say it does, right?
No,
That's why it applies.
Because
say it does.
you just said gravity, these variations could be due to electromagnetism. I am in the middle of explaining how it cannot be due to electromagnetism, and you just won't shut up. So you raise an objection, and then you won't shut up long enough in order to process an explanation as to why your previous hypothesis was wrong. So later on in this discussion, you'll probably come back to the fact that gravity could be electromagnetic, as though that hasn't already been discussed and discarded, because that hypothesis is simply is falsifiable, right? We can falsify the hypothesis that electromagnetism is what produces these variations. And rather than listen to the actual explanation, you're just going to talk over it and move on to another topic and pretend like, well, he didn't get the chance to explain to me why electromagnetism was wrong, so I get to pretend that electromagnetism isn't wrong.
No, you're not. You're giving me explanations without
He's
any
showing you evidence right now.
What do you
showing
think?
me a
What do you
paper.
think this graph is?
You tell me. You're showing me the graph.
It's
Explain it.
measurements of the rate at which the test mass inside an object falls as a function of time.
What did they use to measure this?
The gravimeter.
They used a gravimeter. In this case, a superconducting gravimeter. Would you like to see the documentation for a superconducting gravimeter?
Sure. And if you could also explain how this superconducting gravimeter works and how, it
Do
measures
you
the
honestly
things it
think
does.
that you'd be able to understand the technical specifications behind a superconducting gravimeter?
I don't see why I wouldn't.
Probably because your mum
You're
used
just
your
assuming
soft
that
spot
I
as an
wouldn't
ashtray when you
understand
were a
something
child.
if it was explained to me.
Yeah, because your mum used your soft spot as an ashtray when you were a child, you wouldn't be able to understand it.
All right. Well,
Man,
we'll
all the
it-
character
it-
assassination
well,
and name calling, man. It's really that's how you win debates.
Well, at one of the. Do
This
you
isn't a
consider
debate.
yourself intellectually honest?
Yes.
No, you're not.
Not on the basis of this conversation. On the basis of this conversation, I would disagree with you. Do you consider yourself a good student?
Nope.
I consider myself.
Do you? That wasn't the question I asked, and your inability to answer the question I asked answers the question in itself. If you're not willing to answer a yes or no question with yes or no, then you are neither intellectually honest nor are you a good student.
I don't accept that all information told to me is true because and
Neither do
experts said
I,
it.
sir. And I'm not a fucking idiot who will believe some rando on fucking YouTube over the experiments that I've done. And
Okay.
you did. You made
good
that choice.
student-
You made the choice to obey and believe some random idiot on fucking YouTube ahead of
No.
someone who actually knows what they're talking about. Rather than go and read a textbook, you haven't read a textbook. You don't know what the fuck you're talking about with any of these scientific discussions. That much is
I get it.
transparently
You're
obvious.
mad
So
because
rather
you're
than do any research or teach yourself anything,
Done plenty
you
of
watched a
research.
bunch of YouTubes,
haven't
exposed
watched-
yourself to confirmation
no
bias,
idea
and
where
now
I
you
got my
don't fucking
information
believe
from.
anything
Yeah,
that's told to you. Congratulations, you vandalized yourself.
I understand why you're mad.
Michael, let me be clear.
Okay.
We know exactly where you got your information because we've heard it all
You
before.
don't know where I got my
yes,
information
we do
from. You have
because
no
we've
idea
heard it
where I
all
got my
before.
information from.
Tony, you've heard every single thing you said
so
before,
this is
right?
a superconducting gravimeter.
Mm-hmm.
Right.
Right.
The way it works is it has a test mass, in this case a niobium sphere, that is suspended on the electromagnetic field generated through three layers of superconducting coils that are run around it.
Interesting.
If there is any change in the force that acts on this sphere, that will cause the sphere to attempt to move, which will induce a current in the superconductors, which will force the sphere back to where it was. So by measuring the current running through the various coils, we can determine the forces that were that this test mass has been subjected to. Your first question will be, well, how do you know that Earth's electromagnetic field isn't having an influence? Well, for starters, we surround it in a big metal cylinder, like so, right? Which is made of new metal, which is designed to shield the instrument from electromagnetic influences. And we can demonstrate that the instrument is much more sensitive to the distribution of mass around it than it is to these things. Anyway, that's the instrument that was used.
It uses electromagnetic forces to keep that ball suspended.
Yes, but it detects changes. So if as you say, well, now we can go back to the original paper, right? We can go back to the original paper. If you're going to persist with this idiocy, we can go back to the original paper.
Man, you guys are mad. I don't know
Okay.
why.
No, we're not.
I'll tell you why, because of your intellectual dishonesty.
Yeah.
I'm not intellectually dishonest.
You
are.
are, and everybody in the
I'm
chat
an
can
honest
see it.
person.
No, you're not. You're just shielding yourself. So now, if we look at this figure, you will see, if you look closely, that there is actually a smooth black line. That smooth black line is the predicted value that gravity should have. It is what our models tell us. It is how our models tell us gravity should behave due to tidal effects. What you do not see here is variation in accordance with the electromagnetic field.
Okay.
The electromagnetic field does not obey tidal frequencies, or is not tidally modulated.
What do you think causes the tides?
No, tidal
Gravity.
force is not.
That's how it's measured in a gravimeter. See how it's measured in the gravimeter?
Why does it only affect salt water?
It doesn't.
It doesn't only affect salt water. It affected the niobium in the gravimeter.
I'm saying tides.
Yeah, you can measure tides on Great
occur in
Lakes.
fresh water as well. The magnitude of the effect depends on the length scale over which the gradient is applied. And again, you're talking over the explanation. You ask a fucking question, and rather than shut up for the 30 seconds it would require to get an explanation of why you're wrong, you decide to talk again. And then you have the absolute temerity to go on about how fucking honest you are and how great a student you are.
No, it's a good student.
Shut up and listen. You are being educated.
You're not
being
educated at all. You're not educating me on anything.
Yes, you're not being educated at all because you refuse to shut up.
Because you refuse to learn.
You keep on talking over explanations, and then you say, I'm not being educated. What a whiny fucking baby you are. And it's no wonder you're lost in fucking flat earth fantasy, because you're so whiny that
whining.
anything that is not good in your life has to be somebody else's fault. There has to
My
be
life's
some
pretty great.
conspiracy
Don't know
as
what's
to
changed.
why nobody likes you, as to why nobody respects you
like me. I don't
intellectually,
know.
as to why no one respects your knowledge. And it's
You
not
have no
because you're
idea who I know.
stupid and prone to conspiracy theories. No, that can't be it. It's because the
think
rest of the world is against you. The rest of the world is out to deceive you. The rest of the world is lying to you. That's much more believable than the fact that you're just not that bright. It's much more believable that everybody else in the world is fucking lying and too stupid to see through the lie, rather than you're just a fantasist. Given a choice between those two hypotheses, it's clear that a worldwide conspiracy spanning fucking generations and hundreds of thousands of people is the vastly more plausible explanation than the fact that you're just a bit thick.
No, I don't think it's. I don't think everybody's lying. I think people truly believe what they were educated. Okay.
Yeah, educated.
And that's not. And the fact that everybody else is stupider than you is much more plausible to you than the fact that you're a bit of an idiot and you didn't bother to pay attention in class. That's the more plausible these two hypotheses exist side by side in your head, and you're going with the one, well, everyone else is the fucking idiot. I'm clearly the super genius.
I never said that at all.
I'm smarter than every fucking scientist who has existed for the past 400 years. Yes, you are. You're saying that the evidence is transparently false, and you're smart enough to have worked it out. But every professional scientist who has dedicated his career to this for the past 400 years is so much of a fucking blundering idiot that they can't be trusted to tie up their own fucking shoelaces. But you, the fucking idiot with zero real world accomplishments, you're the one everyone should listen to. You're out here in public explaining to the rest of us how we're fucking losers. That's the temerity you have.
I never said anything. I never called you a name.
No, but it's what's going on in your mind in order for you to be here. In order for you to be here, you must believe that every scientist is wrong. If you don't believe every scientist is wrong, you wouldn't be here.
My life sucks. It's like, dude, my life doesn't suck at all. What do you...
It does! If it didn't suck, you'd have something better to fucking do than to spout fantasies on some online forum while a few hundred people laugh their asses off over just what a dipshit you are.
If my life sucks because I'm on the show, then
they admire your intellectualism.
You're right there with me.
They're not here because they think you're a great speaker. You are literally the dumbest, least informed Flerf that this channel has had on for a year. Really? And that is up against some pretty fucking stiff competition. There are idiots from South Africa who are being made to look good compared to you, by you. There are literal half-wits in Canada who at least seem likable compared to you. There are there's a guy in Canada who got sacked from his job as a delivery bike rider for being a flat earther, and he comes across as smarter and better informed than you.
Get off on this or something?
So if you think you're here achieving something constructive, the only thing you're achieving is making yourself look like a competitive A-grade dumbass on a global scale.
Man, I'm watching you have a meltdown right now.
I am famous for yelling at Flerfs. And, in fact, contrary to you, the audience enjoy hearing me yell at flat earthers. They think it's funny. I think it's funny.
Conversation about the subject, apparently.
Well, we could have had, except for your continual dishonesty and fucking snide jibes. And eventually, and then you have again, it's this whiny, look at me, I'm the victim. Everybody in the universe is fucking engaged in this.
I never said I was a victim. And I never said anybody else was lying.
People aren't polite and they don't listen to my bullshit when I spout it, and I refuse to listen to the explanations as to why I'm wrong. And then people get angry with me.
I'm not trying to
they're so unreasonable getting angry with me. You're a whiny, deluded fuckwit.
I never said anything like that.
That's why you're in the situation that you're in.
My situation is great. What are you talking about?
You're being laughed at by 300 people. You've been
424 actually.
That isn't a great situation to be in.
It doesn't bother me at all.
Laugh harder. You have publicly humiliated yourself. You may as well get up, turn around, and pull your pants down. That is how embarrassing this has been for you.
That's great if you care about what other people think about you. If you're that insecure, you know what I mean, that would be a really bad spot to be in. But I'm pretty secure in my life, and I don't really mind if people laugh at me.
When you're delusional, you have absolute confidence in your delusion, and you don't care that the rest of the world disagrees about your delusions.
Right.
The only reason you're not in a mental hospital is because of your country's lax attitude to mental health and the funding of public facilities. That's the only reason a delusional narcissist
because I wasn't a good student
is still walking the streets.
Accepted and repeated everything I was told in class on a test.
You never understood anything.
No, I got it.
Because you're delusional. You have disconnected yourself from reality. We could have a reasonable discussion about whether or not what you were told in class is adequate, but you're not having that conversation because whenever you make a reasonable proposal, and then when I say, well, it's wrong because of this, you don't stop and listen to why it's wrong. You start making snide comments, and then you start trying to shift to another topic of conversation. We could still be explaining how we know that gravity isn't due to electromagnetism, but you're too much of a fuckwit to let the conversation linger on that topic for more than 5 seconds before realizing you're about to get your ass handed to you and deciding that the best defense is to shift the goalposts again.
You have a really great imagination, friend. I know. You've made a lot of assumptions about my life and compared me.
Put
words in my
mouth
that I never claimed.
They're not assumptions. They're conclusions drawn from evidence. The evidence before me is that you have nothing better to do than this with your life, and that you have spent apparently by your own admission 10 years of my belief. 10 years researching flat Earth without opening a physics textbook, without bothering to talk to a physics tutor, without bothering to inform yourself on the nature of gravity and the experiments for it. Do you know what a geostrophic wind... You talked about rotation. Do you know what a geostrophic wind is?
You're going to tell me wind measures the rotation of Earth?
Yes.
If you understood physics, you would know why.
No, speed is...
You can go get a random weather map. Get any weather map on a reasonable scale and look at the wind direction.
Is speed measured by observing an object over time?
Again. You've seen a semi-trailer coming to run over you, and you've decided to step to a different topic. Wind direction. If you are, let's bring up the fucking presentation again. Jesus.
It blows a lot of different ways.
And you keep on wanting to talk for...
You're not going to measure the speed of Earth by looking at wind.
Yes, it's one of the ways that we can measure the speed of Earth is by using the geostrophic winds.
By observing something completely different is how you measure the speed of Earth.
It's one of the ways we do, yes.
That's not how we measure it.
By observing something completely
That's not how we measure it, you fatuous moron. We measure it using instruments. We measure it using instruments.
You measure
what I'm
you're measuring
saying
the wind?
Is that you can see the effect of rotation.
Is the wind Earth? Is the wind Earth?
The wind is on Earth, is it not?
The wind, but the wind can blow all different directions.
So the wind is
and the Earth doesn't move.
Earth's motion, right? So if the Earth is rotating, that should show up in winds, right?
How does the wind on
Coriolis force, mate. Do you know what Coriolis force is?
No, of course he doesn't.
Yeah, because you totally have wind without you wouldn't even have air pressure.
Do you know what Coriolis force is? Yes or no? Michael, show that you are intellectually honest and answer the yes or no question. Do you know what the Coriolis force is? Yes or no? Do you know what Coriolis force? I said force. So do you know what the Coriolis force is? Yes or no?
Educate me.
Yes or no?
Okay.
No, off the top of my head, no.
Right. Well
I
done.
don't see how that applies to the speed of Earth
So-
and how you measure
Because
it.
Well,
it's directly
let's-
respond. Oh my god.
Let's go with this explanation. Okay, so
More explanations.
if you have a high pressure system and a low pressure system, you have a gas at high pressure and a gas at low and low pressure over there. Where should the gas? How should the gas move?
should come to like it should.
From the high pressure, it should
to the lower-
move towards the low pressure, right?
Yeah.
You didn't know that.
So, it
So-
equals out,
Yeah. Okay. So, and it should move with a speed equal to the gradient in pressure, right? The higher the pressure difference, the faster it should go.
yeah.
All right. So I'm glad we can agree on some element of reality. Let's start the share again.
Now, I want to.
Here's a weather map.
Okay.
You can see the isobars, the points of air pressure are measured in brown lines.
That's great.
There's a low pressure here. There's a low pressure there, but also marked on the map are wind directions.
Uh huh.
So if we point up the wind maps,
Uh huh.
you can see that the wind flows along the isobars. But that's not what we just decided should happen. What we decided should happen is that the wind should flow across the isobars. It should flow directly from the high to the low. But it doesn't. It flows along the isobar. And, more importantly, it flows in a set direction.
And this
If
is
you're in the
observing
northern
Earth.
hemisphere and you sit on the high pressure side, the wind will always flow to the right.
And is this observing Earth move from
If you
point A to
want-
point B?
we'll
over
get
time?
there. We'll get there in a second.
Not gonna
How
get there.
about you shut up while you're learning?
I'm not going to get there, but okay.
Okay. So we expect
I bet you've
that
never
if
got
there's
that.
a high pressure system and a low pressure system, that the air should just go there. But what we instead observe is that actually as it moves, and you can do this with balloons, you can release the balloons, that as the air parcel moves, it is constantly deflected until it ends up flowing along the isobar rather than across it, right? So that the force towards the low pressure system and the force towards and the deflecting force are large enough to offset one another. This is due to Coriolis, right? This deflection is due to Coriolis effects. Sorry. Okay. We can see the same thing in ocean gyres. So here are the major ocean gyres in the oceans of the world. You can see that the ocean gyres go clockwise in the northern hemisphere, but they go anti-clockwise in the southern hemisphere. Right?
The farther away they get from the center, they act different ways.
Yes, that's
Now,
right.
Can you connect this to observing a point on Earth go from point A to point B over time?
Yes.
Go for it.
Okay. So we observe, solar storms, when they impact Earth, we see the Earth rotate relative to the solar storms. Stellar positions in the star vary in response to Earth's rotation. Since you want to get into this rotation thing, let's bring up another presentation.
No, I said, can you connect it to observing
Yes, I know what you asked.
Earth go from point A to point B over time?
Yes, and I can.
I'm waiting.
Well, we're going to get there.
Okay.
Yeah, you keep saying you get there. I mean,
So
not
Do
getting
you
there.
accept that there is some deflective force operating on air?
Yeah, I never
before
said,
we
I
move
never
on.
said anything about air. I asked you.
Okay, no, that wasn't my question. My question was: do you accept that there is some force that is deflecting air and water to act in a certain move in a certain lateral direction? Yes
Yeah,
or no?
There's
Yes.
definitely different
What
wind
is
patterns,
it?
different areas.
What? Well, why would wind patterns vary with hemisphere?
I mean, we're living in an
Why would they
electromagnetic
change
field,
by
right?
180 degrees depending on which hemisphere you're in?
Do you live in
Wind
an
patterns don't
electromagnetic
do that.
field?
No.
You don't live in an electromagnetic field?
Well,
There aren't electrons flying around you
show
all over the place?
show me in a laboratory electromagnetic fields having that effect on air and water. You can't because it doesn't. Also,
there's electrons flying all around you.
Pardon?
There's electrons all around you in the atmosphere. The atmosphere is electrically charged.
Free.
They're
not free. There aren't. They're
electrons flying all over the place.
They're generally attached to atoms.
Yeah, everything intrinsically, when you break it down to like atomic, has a positive and negative. It's all,
no, that's not. That's
electric.
false.
Yeah,
that's false.
Okay.
Neutrons do not have an electric charge.
Okay. Now you're saying there's no electrons everywhere around.
Taken by
there aren't
NASA's
electrons
Epic
flying
camera.
all over
I'm
the place.
saying that there aren't that many free flowing electrons. I'm
Really?
saying that the electrons are generally attached to the atoms that they're components of.
And electrons fly a lot faster the higher up in altitude you go, right?
What makes you say that?
Well, there's less gas molecules for them to travel through.
And what difference in speed would that make?
That makes no sense whatsoever.
Like you can conduct electricity a lot easier higher up in the sky.
Can you?
Any evidence of that?
Electrons move a lot faster, yeah.
Any evidence you can give that?
No. Where's your evidence for that? What's your basis
pressure.
for making this claim?
I mean, it's science. You have PhD, right? You don't know how electrons act when they slow down as they go through molecules. The more gas.
Have you got any evidence?
Go through molecules.
Right. Simple question. And I just want a yes or no answer, Michael. Do you have evidence that you can conduct electricity easier with altitude?
Do I have evidence?
You just made a claim. Have you got any evidence?
That electrical forces move around freer higher up in altitude where there's lower air
Yeah, have
pressure?
you got any evidence that you can conduct electricity easier? Those were your words.
I mean, I thought that was pretty settled science.
No, science isn't settled.
Are you denying that's true?
Have you got evidence that it's true?
I don't, but are you denying that it's true?
I'm denying you've got any evidence that it's true.
You're saying that isn't
I'm
true.
I'm denying. I'm
saying I'm wrong.
I'm denying your
You're saying
explanation.
I'm wrong.
No, what you're saying is wrong in that resistivity of the air decreases as you go higher. That's got nothing to do with the velocity of electrons.
Do electrons
The
slow down?
so resistivity decreases as you go higher in altitude because air is less dense, but that's got nothing to do with electron speed.
So electrons don't slow down as they pass through gases?
No.
Okay. If you say so, boss.
Right, and just so
Where are you getting these from?
He's just saying random shit. Michael,
I'm
on
not saying
screen,
random
on screen
shit.
right
I mean,
now.
This is pretty
You are-
settled science, dude.
Right.
No, it isn't. Electrons are deflected by atoms. Or
The shape of the
molecules.
Earth is settled science. We know it's a globe. Right. Anyway, Michael,
don't
just
know. I
quickly.
mean, you think it's a globe.
Michael, no, I know it is. I measured
it's a
it. Michael, just
wow.
quickly on the screen is Earth moving from point A to point B. So we've measured the
Yeah.
rotation of Earth.
You're showing a spinning picture of Earth.
From the Discover satellite, which records it 24 hours a day.
Satellite.
Yeah. Records
Right,
Earth 24 hours a day. So
Yeah.
this is obviously a time lapse, but yeah, you can see it 24 hours a day, and we can see the speed of Earth rotating from A to B. So yeah, we know how fast Earth rotates.
That's pretty damning evidence right there. You got satellite footage that
Yes,
can't be faked. Can't be photoshopped or
Have you got any evidence that it's fake, or you just
Have
making
you
a
got
claim?
any evidence that isn't photoshopped that contradicts it? Do you have satellite footage? Do you have
need
satellite
satellite
footage of the
footage.
Earth being stationary?
I mean, I don't need satellite footage.
Yes,
No,
you do.
you don't. Do you have instrument measurements saying that the Earth doesn't rotate?
I get it. You believe these videos that NASA shows you, and you take it as evidence because
But I don't need a video to prove the Earth rotation. I can measure Earth rotation with instruments, right?
no, you can't.
Yes,
Yes,
you
you
can. I did
can.
it.
You can't measure the speed of something
Yes, you can.
if you're not
Yes, you
observing
can.
it go from
So-
A to B.
Well, I've just shown you that.
You didn't show me that. You showed me a video that compiled by NASA.
Yes, it's a
Who's-
video made by NASA. Correct. Have you got any evidence that it's not real?
historically
Okay, on screen we can see an experiment. This was done by a chap named Ferdinand Reich in the 19th century. He dropped lead balls down a mine shaft.
I see an experiment.
And
I see cartoon.
okay, you see an illustration of the experiment.
He's doing a
And
CC.
the
Not the actual
experimental
experiment. Not the actual experiment. Got it.
Okay,
You're just taking this.
did
as
you
truth.
notice that the experiment was done in like 1827?
That's what they claim.
What better documentation did you want? Did you want like an IMAX crew there?
I mean, could you recreate
Did
it?
you want to go and do the fucking experiment yourself?
Yeah, it could be recreated. Yes.
It could.
Yeah. So go and do it
Yes.
if you doubt it.
But we've got better instruments now, so we don't need to.
Sure. You do.
He dropped a ball down a 158-meter shaft,
Sure he did.
and noted an eastward drift exactly in accord with what you would measure,
bet he
provided that the Earth were rotating. You've got
you say so.
Foucault's pendulum. You've got mechanical gyroscopes that observe a precession and a tilt. You've got your gyroscope set up. As the Earth moves under it, it will tilt because it's trying to stay in the same plane.
You believe these things because you trust.
No,
I
I've used a
believe
general.
these
I've
things
used a
because-
mechanical gyroscope.
I believe these things because they're used to make planes work.
They're used to make planes
The
work.
principles, the principles behind mechanical gyroscopes were used to make planes work and to
Yeah,
keep
the
planes
derivation
from
and
crashing.
deviation
So,
of a aircraft moving at a constant
yes, I
speed.
believe these things.
When you design a plane-
Here's the Compton generator, which is a
plane was
different
designed-
technique. It relies on a. So you keep on going. Are you just going to say that's fake for each
No,
experiment?
I'm not. I'm
that's coming
saying
to you?
I was saying that the derivation and deviation for an aircraft moving at a constant mass, like the linear equations.
Can
for
you show me
designing
an aircraft of
airplane-
constant mass?
There's no such
Okay,
thing as an
airplane?
aircraft of constant mass.
Airplanes burn fuel, therefore they lose mass.
Also, airplanes aren't rigid. They're in fact designed to bend, very much so, especially the wings. Also, weather's a thing, but not according
they're
to
designed
that
to fly
modeling
over
assumption.
flat and level surfaces, though.
So,
No.
like all of the other assumptions, that were just shown to be false, the aircraft aren't rigid, aircraft aren't constant mass. The assumption that the Earth is flat is similarly false. And any documentation you've seen in which they have assumed these three things are true only for approximations.
For approximations, okay.
Yes.
I got it right here.
Right. As you're
send the
such a
link
baby
to the
Flerf.
document.
No, we've seen this before. This is why we say you are a baby Flerf. We've
Not a
seen
baby
the
Flerf.
documentation, and we know what else it says. It says that the aircraft are rigid. It says that the aircraft are constant mass, and it says that and it makes assumptions about the negligibility of winds.
Also, it mentions gravity
So we've
37
seen
times.
all this.
I'm
A
sure you've
million
seen the document, right?
showing-
Yes.
And you're not showing us anything that you haven't seen. We are showing you stuff that you haven't seen. This is the
You're not showing
Compton
me anything.
generator. It is a glass annular. It's an annular
If you
glass
could
cylinder.
Bring up the
that
summary of that
contains-
document.
Flux, pardon?
So I sent a link to a document. You could just bring up the summary to it.
Okay.
We've
Are
all
you
seen that
listening to
document
the evidence
before.
that contradicts your position
You've
or
seen
not?
it, yeah. It says right in the summary. This report documents the derivation and definition of a linear aircraft model for a rigid aircraft of
Model,
constant mass flying
not
over a
real.
flat,
It's a
non-rotating
model.
Yeah, so it's a model.
It's a modeling
and the model is
simplification.
only as accurate as its underlying assumptions.
Earth. Linear aircraft model, yeah.
Yeah, it's
Yeah.
not. It's not an actual
So
thing.
it's a
It's a modeling
mathematical
assumption.
model.
So
you
when
know
you're
that
designing
document, this document here
the
mentions
linear
gravity
equations for
37
airplanes.
times. Michael,
you're
listen.
designing.
Mike, listen, shut the fuck up. This document mentions gravity 37 times. Were you aware of that? So if you're saying this document is true, you're also agreeing that gravity makes a downward acceleration of 9.8 meters per second squared and is based on the attraction of mass
Absolutely
to
not.
mass.
Well,
No.
but you can't introduce a source and then say, well, I reject what the source says,
You don't
except
have to
for this
agree
bit
with
over
everything in
here,
the source.
where I
Yes.
cherry pick out.
Why do I
where
have to
cherry
agree
pick
with
out a
everything in the source
mathematical model?
material?
Again, you're talking when you should be listening.
Okay.
You know, and this is you know, you are being walked through. We have a dozen different styles of gyroscope that all detect. You know, this is a superconducting gyroscope that detects Earth's rotation. This is a magnetically levitating sphere that detects it. This is a micro electromechanical one. So this is on a computer chip. We've got a gyroscope that can detect Earth's rotation. We've got ring laser gyroscopes. We've got gyro compasses that demonstrate that the Earth is that only work at the Earth rotations. We've got direct measurements of Earth's polar rotation and its measurement. We've got measurements of the variation in the length of day, how long it takes for the Earth to complete one rotation that are measured during using different instruments. We've got measurements of the tidal oscillation in how long in angular velocity. We can measure these with absolute precision using instruments of mind-numbing sophistication and
Mind-numbing sophistication.
Here's Remy,
Because you can't understand how they work.
No, we understand. It's just boring.
You don't
understand this
understand
is
how they
boring.
work. You don't understand how they work, and you
Yes,
can't be
and you've
bothered to
used
do
all
the
of these-
homework. And this again comes back into his victimhood. You haven't explained to me simply
I'm not a
enough
victim here, bro.
how this works. Therefore, I don't believe it does. I'm not going to go and research it. I'm not going to go and read up on the technical papers. I'm not going to go and educate myself with enough basic physics that I understand the principles of operations of these things. No,
You believe in
instead I'm
theoretical
going to
physics?
sit here and whine that you
not
didn't
whining.
explain it
You've
well
done a lot
enough
of
to me,
whining.
and I'm just going to reject it because of that. So my
I'm
laziness,
rejecting it because-
my mental
Because you're dumb.
incompetence,
Observable
that isn't the
evidence.
problem. The problem is that nobody is spoon-feeding me. Nobody
No.
is out here spoon-feeding me the facts.
You ate
I'm
all the
saying, here
spoon-fed
comes the
information
facts.
and you ate
Open, here comes the airplane. Open the
Reject
window.
it.
Nobody's fucking
You-
spoon-feeding you stuff.
Right, let
So
me show you this-
just
You're
decide,
telling me
Michael,
spoon-fed
I'm
right,
not
stop,
going to
stop,
believe anything.
guys.
All
Michael,
of this
Michael,
information
shut,
was
Michael, shut up,
spoon-fed to you.
Michael. I'm going to show you a video.
It was spoon-fed to you.
Michael, I'm going to show you a video by a flat earther. All right, just pay attention for 30 seconds. Keep your meat
What does
hole
that
shut.
have to do with me?
It's a I just want you to watch this video made by another flat earther. So shut the fuck up.
Don't see how this has any
Every
relevance.
24 hours, that means that
I'm not
To what he said. Just
aligned
watch.
with
if
this
the
guy.
Earth is spinning at
Just shut up and watch the video. Don't say anything. Just watch the video. Okay?
No, Craig, I need to make a point here. He has decided before he even sees what is on screen, he has decided that it is irrelevant, that it doesn't prove anything, and that
Has
it
nothing to do with my
has
beliefs.
no bearing on this conversation. He has decided that what you are going to show is not evidence before even seeing it.
Yes.
So
Okay,
he
what-
has
what somebody
he has,
else is
this
saying-
is the opposite. This is the opposite of intellectual
no
honesty. This is
I have
the
no idea who
opposite.
this guy is.
This is the opposite
doesn't
of scientific
matter.
investigation. First,
matters.
you look
No,
at
it
the
doesn't.
evidence, then you
You're
come to the
suggesting that I believe
conclusion,
the same thing
not
that
the
this
other
guy-
way around. You dipshit.
You believe the
You're
earth is
suggesting
flat.
that I-
Everything that you've said is the same things that this guy believes. So just be quiet for 30 seconds. Do not talk. Shut the fuck up and watch the video. Spins.
Go for it, man.
Let's have a listen to what he said.
if the Earth is spinning at one rotation every 24 hours, that means that every hour it has to turn 15 degrees. And if the gyroscope is mounted anywhere on Earth, it's going to drift. In today's 21st century navigation systems, they're using what's called a ring laser gyroscope. It is extremely precise. If we could simply get one of these ring laser gyroscopes, we would be able to prove once and for all that there is no rotation to the Earth. One of the people in the community actually purchased one for $20,000. But what we found is when we turned on that gyroscope, we found that we were picking up a drift, a 15 degree per hour drift.
There is a direct measurement of the speed of the rotation of the Earth.
That's what some guy who was probably paid to say, said on a video.
He died because of his unwillingness to listen to doctors.
Yes.
So, he's one of our shills. He's one of our shills. He died because he didn't have his diabetes.
COVID vaccine or something? How did he die?
No, he died because he didn't get his diabetes treated properly, which is a common affliction amongst flat earthers. It happens more often than you'd think.
He died because of his diabetes, and that means it's worth in that video.
It's worth noting that what he's measuring, how do you know he measured anything? That is how the gyroscopes on planes are calibrated. They are turned on, and then they are calibrated against Earth's rotation. And it is only if they can get a correct measurement of Earth's rotation that they accept that it's accurate. So every successful plane flight that ever occurs is because gyroscopes work and because they correctly measure Earth's rotation. And you can shake your head with your fucking smirk like you're a fucking idiot. You're just ignoring evidence. And everybody in the chat
that wasn't evidence.
Okay, well, all right, here's the evidence then.
That is evidence.
Right, here
a video
here he is. All right, shut up. Michael, shut the fuck up. Here he is later on in his house at his computer using the device showing that it measures movement.
And that's right? Then you believe it.
So
yeah, he's showing it through the thing.
Aircraft and see my front of my hand is the
why would we not?
Front of the plane. All right.
Why would you not?
You can see this thing right here.
He's just claiming that is that a laser gyroscope right there?
Yes.
Is an attitude or
that's a laser gyroscope.
Yes, and he's got it plugged in.
And Bobby's right.
It's in a case.
It's in a case.
Do you have object permanence? you can put something in a case and link it up to the wiring that goes around it. It'll look different.
And here is another one on a globe. Here is it. All right, shut up. I'm talking. Be quiet. Good boy. Here is another one actually on a globe. This is a pilot, Wolfie 6020, and he has a laser gyroscope on a globe.
In a level attitude, as it would be level sitting on a desk, you can see that it is not polar aligned. And if I rotate that globe, we're going to register movement in all three axes. There you can see
so he put it
the drone is rolling, pitching,
globe.
And yawing.
Yeah, and he's showing you that it is measuring the rotational speed. That is the same device showing that there's actually physically happening, measuring the rotational speed of a globe that it is attached to. So showing that the same
thing. Take it off that globe and put it on the ground.
Yeah, you put it on the ground. It measures 15 degrees per hour.
Those are two different things, bro. Like he had it on a globe, showing that how it would work on a globe, and he moved the globe around.
Yes, and what it did, right? Yeah, shut up, shut the fuck up. What it did, shut up.
Yes, it does. It detects 15 degrees per hour.
When you put it on the ground, when this thing is on right now, this one that Bob has, the second he switches it on, just leaves it on his desk, it measures 15 degrees per hour, showing that it is. Yes, that's what this is all showing. And then it shows that when you put it, and then it shows that when you put it on a globe and move it, it measures the rotational speed because this is a lot faster. But if this was just sitting on, he showed you it over here. Did you not just watch the video?
Show me where he puts it on his desk and it's not moving and it's measuring 15 degrees.
You can see that it is not
plane. All right.
As soon as he turns it on, that's what they're saying.
Okay.
Okay. Well, let's see it. Is he moving it around?
I could send you the raw video that this is clipped from, where he turns it on and shows that it's doing that. But I didn't have that particular clip in this bit. He does just have it on his desk in that video. Oh, here it is. There's the bit. And so when it's just sitting on the desk and it's turned on, it's still measuring 15 degrees per hour.
and it's measuring 15 degrees an hour.
Can I ask, at any point were you going to show any fucking evidence at all of anything?
No, he wasn't.
So you're here asking, where's this? I don't see that. Show me a video of it. Blah 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 blah. And you've got no fucking evidence of anything.
Just showed physical
the closest you've come to evidence are mathematical model assumptions from a paper that everybody's seen a million times, and is just not a description of reality. It's a description of a mathematical model that is only as accurate as the assumptions permit.
I've demonstrated.
You've shown no fucking evidence of anything whatsoever, but you insist on saying, well, I don't believe that because it contradicts my belief that I have no fucking evidence for.
I've asked you since the beginning to show me where you observed a part of Earth.
I showed you it, and you said it was fake.
Yeah, that's not an observation that you made. You're showing a video.
Why does it have to be? That's the genetic fallacy. It doesn't have to be that I made it.
Because it's unobservable.
No, it's not. I just showed you it being observed.
You'll never see a part of Earth go from point A to point B.
I showed you it from a satellite in space.
You showed me a series of images that were compiled by NASA.
Videos are series of images. That's what a video is.
Okay,
Okay, so do you understand? So the sun goes from being overhead on the equator to being directly underfoot on the equator, right? We can detect that the sun is directly underfoot using neutrino detectors, right? So we can detect the position of the sun as it moves under. We can follow it through the sky, and then we'll keep on following it, and it'll go underneath the Earth, and you can follow it up the next day. So we can do that. Now, either the sun is moving or the Earth is moving. That, by the way, would be
moving. Because we observe the sun go from. Because I'm observing the sun go from this point to that point in the sky over.
If you're driving in a car, if I'm driving in a car, I see a tree going from there to there. Does that mean the tree is moving?
No. But you know that the car.
Okay, but so how do you know? That it's the sun moving and not you?
Yeah.
Because I'm not moving.
How do you know that?
How do you know?
Because
how do you know that?
Earth is the baseline.
Not according to all measurements. All measurements show that
that isn't evidence of
relative
anything,
speed.
I don't know what science class you went to, but
He
this
didn't
is
go to
not
any,
fucking
Tony.
evidence or an explanation of anything.
Okay, you're using relative speed as an excuse. Like it can't be. Like you could tell how fast a car is going by measuring the revolutions per minute of the wheels.
Yeah,
yes,
and you can also measure revolution per minute of Earth.
You can measure,
you know that the car is
measure
traveling
how
at speed.
fast Earth is rotating by using a ring laser gyroscope, or a mechanical gyroscope, or a matter wave gyroscope, or a magnetic levitation gyroscope, or a superfluid gyroscope, or a Compton gyroscope, or just by dropping balls, or by looking at Coriolis effects on wind or on hurricanes, or by looking at ocean gyres. The evidence that we have that it is the Earth that is moving is insurmountable, and you just saying, well, I don't see it. You haven't looked at the right fucking instruments.
Well, you can't explain to me how a gyroscope observes Earth moving from one point to another over time.
Yes, I can. We did.
Go for it. You didn't.
Okay, let's go back to sharing.
Are you going to explain the Sagnac effect to him?
I did show you how that happens.
Your best evidence is images from NASA that were compiled.
No, he needs to have the Sagnac effect explained to him, because that is literally what he is asking for, right?
Floating up there.
So I'm sharing on screen. You have a laser source. You fire the laser out. It bounces on a mirror, and it goes to the detector. But the mirror is half silvered, so we've got half the laser goes around the other way, okay, and ends up at the detector. Now, if the instrument is completely stationary, then these two waves should when they meet the detector, they should still be in phase, right? They've traveled exactly the same distance, so they should be exactly in phase. But if the mirror is rotating, if the apparatus is rotating, then one of these waves is traveling further and the other one is traveling a shorter distance because the mirrors are traveling towards one of the beams and away from the other one of the beams. So when they get to the detector, they will be out of phase. So we look at the phase difference between the two beams when they meet the detector. That is how a ring laser gyroscope and indeed a matter wave gyroscope works on roughly the same principle.
You verified that this is exactly what's going on in the machine?
Yes.
Yes.
Yes?
So with a physical gyroscope, we can see, for instance, tilt as the rotation occurs, and we can also see a change in heading, right, as the Earth rotates. Because the axis of rotation, the axis around which the gyroscope rotates will stay the same, it'll appear to precess as the in this case an anti-clockwise fashion as you look at it from above. So yes, with mechanical gyroscopes, that's how you do it. If you had bothered to shut up earlier, I would have explained to you how each of these gyroscopes fucking works. So now that we've got a moment's silence, this particular style of gyroscope works by having a glass cylinder full of water. It has little flakes of ash or carbon in it, and you let it rest for a long time, so that the flecks of carbon are stationary. Then you quickly flip the apparatus over, and you will notice, if you look through this microscope, you will see the pieces of ash start rotating against, they still have the momentum given to them by obeying Coriolis. Now you've reversed the effect of Coriolis, they start to move under it. This is a cylinder of superfluid that should not be affected unless you're moving. It should not be affected unless you're moving the entire apparatus. You should not get any flow. By measuring the flow through this aperture here, we can tell how fast it is rotating. In this one, we suspend a plastic ball. So this is a plastic ball with lines drawn on it, so that we can measure the change in attitude. So it's attached to nothing. It's just floating on a magnetic field, and we can observe the ball rotate through time, and that gives us a rotation effect. So there are entirely different mechanisms, entirely different physical processes that are being used to measure how rotation occurs. And again, you could have at any point gotten off your fat ass and actually read through this yourself, because you're saying this was spoon-fed to me. No, it wasn't.
It was.
I went out and I researched and I read this myself outside of a class in my own time. And I put this presentation together for the benefit of people, and for the benefit of people who, no, it wasn't part of my PhD thesis. No,
spoon fed it to yourself. Yeah, you read it and you believed it and you ate it up. I got it. Said you read it and you believed it.
I read it and I read it. I also happen to work with people. I also happen to work with people who work with these instruments, so I can talk to them at conferences.
Great.
So I can ask them. For instance, my work actually involves using satellite data. So the idea that satellites move at low Earth orbit at 7 kilometers a second. Try explaining that. What are they doing? We can track the satellites.
Couldn't possibly be attached to weather balloons, like how to do weather balloons.
I think someone working on them would know.
They can move at a lot of different speeds.
Do they move at 7 kilometers a second? Can you show me a wind that goes at 7 kilometers a second?
Who says that you couldn't attach a fan to one to make it 7 kilometers a second?
7 kilometers a second. What's the fastest aircraft? How fast is
the X-15, I believe.
What's its speed in kilometers an hour?
I don't use kilometers where I'm from the U.S.
Yeah, that much is fucking obvious.
Yeah.
Because you've got no idea how fast 7 kilometers a fucking second is? Do you know how many seconds there are in an hour?
7,274 kilometers an hour.
Right. Okay. How many seconds are there in an hour?
I mean, you think about it, if there's no real like air resistance
How many
higher up in altitude,
How many seconds are there in an hour?
things could move pretty fast, I'd imagine, when there's like zero
How
air pressure.
many seconds are there? Yeah, you keep on saying this, and there are 3,600 seconds in an hour, right?
Okay, you're claiming that
So
that these
20.
objects
So
are traveling
so
that
this
fast.
would be, so this object is moving at 25,000 kilometers an hour. So that is more than 3 times as fast as the fastest ever aircraft.
And you're measuring, you know that these things are traveling that fast because
He
observing
works on
them
them.
move that fast.
One, we can laser range to them. They have little retro reflectors set up, and we can laser range towards them to confirm where they are. Two,
Do you see them?
GPS receivers on them that tell us their positions as a function of time, and from the positions we can work out how fast they're going.
And they shot them into orbit. Once they got to a certain altitude, they just stopped being pulled by gravity and got thrown into a circle.
Well, no, that's gravity's making them orbit.
That question betrays a profound misunderstanding of all physics, and I invite you to actually crack open a physics textbook
Orbital
and
physics
read
are very
about how orbits
theoretical.
work, because
No, they're not. They're
I'm
used
not
every
going
day.
to explain it to you.
Not used every day.
They're used every day. Like
It is
SpaceX.
used every day.
Last year, SpaceX launched a rocket to space using orbital mechanics nearly once every other day.
Yes. I bet they did. You know, if you believe what they claim.
You
then
can go and
sure,
watch the rocket launch yourself, you dumbass.
You can watch it go where?
If you've got
Into
if
space?
you've got an appropriate laser, you can laser track them. You can watch them go across the sky. If shortly
Like my friend
before
Astronomy
dawn,
Live
shortly
does.
Shortly after sunset, you can see them go across, and you can see when they're going to go into eclipse.
My buddy
these are
Astronomy
pretty
Live,
cool.
Fly right
Michael,
into the ocean.
my buddy Astronomy Live used his own personal equipment to track Artemis 2 all the way to the moon and back.
He did he?
Yes,
That's amazing.
his own personal equipment,
And,
which he invites flat earthers to come and use, and none of them ever take it up.
I mean, you're not. How did he observe it go all the way to the moon?
Because he tracked it with his equipment.
What is how? Yeah, but what is his equipment? How did he track? How did it track
A
its
mixture
movement?
of optics and radio wave transmissions and things like that.
So he used radio waves to track.
He used many
something
different
travel
methods.
30 million miles, or fucking
Yes.
235,000 miles away.
Yes.
He's sending radio waves 235,000 miles.
Yes.
And to watch it.
Yes.
It's amazing.
No,
I'd love
you
to-
can
I'd love-
you can actually point an antenna towards the craft and listen to the radio waves. Right?
Okay, so you're listening to radio waves, and
And
because
you
it's
can
radio
calculate
waves
where
coming
they've
back
come
to
from
you-
because you triangulate them from other points.
right 235,000 miles away. Gotcha.
Yes.
Yeah. Sure.
So your denial is noted. Right. Anyway, Tony, I want to
Yeah,
thank you for coming on.
definitely.
I'm gonna read through the questions in super chats now, and I think
All right,
you
I'm
deserve to
going
go
to
and get yourself a
leave.
coffee. I want to thank you very much for coming
well, I
on.
don't drink coffee, but I'll manage.
Maybe a margarita or five. I don't know.
definitely need to.
You are
something to calm
a
down, like maybe some
complete
tea or
fucking
something,
waste of otherwise useful biomass. And
Yeah.
if
That's
it,
great,
it the fact that we cannot even use you for testing cosmetics on is the granny state gone mad.
Have a good
Right.
day, Tony. Thank you very much.
Have a good one, bro.
Right, dude. I want to be clear.
That dude was mad.
You
I don't know.
do not understand anything about physics in the slightest.
Yes.
You have
if
not
say
even
so,
a
man.
cursory knowledge of anything regarding physics or the way that maths works. Could you even tell me how many?
say this
If
all
I've got
day.
right, let me ask you a very simple question. If I've got a triangle of sides 1, 1, and 1, what would the internal angles be?
What does this have to do with with the shape of the Earth?
It's what I call a litmus test to gauge the person's ability in mathematics and general knowledge.
Did I claim to know everything about physics?
You claim to know physics. You claim to understand physics very well. That was your exact words. But anyway, the question is, and I need to know so that I can gauge questions for your intelligence level. If I've got a triangle of sides 1, 1, and 1, what are the internal angles?
You're asking questions.
Yes, I'm asking you a question, and if you're intellectually
claimed...
honest, you would answer it for me. If I've got a triangle of sides 1, 1, and 1, if I've got a triangle of sides 1, 1, and 1, what would the internal angles be?
Okay. I never claimed to know everything about physics.
You said you understand physics very well. Right, but anyway, the question is, I've got a triangle of sides 1, 1, and 1. What are the internal angles?
I have no idea.
Why not? How many angles are there in a triangle? How many degrees in a triangle?
3.
No. How many degrees are there in a triangle? In total? Are you kidding me?
No. What's your point here?
Do you know how many degrees there are in a triangle, yes or no?
How does this relate to the debate? Is what I'm trying to figure out.
It shows your level of intelligence and that you think you're
questions.
smart enough to dismiss all of science. Right, I'll try and make it easier for you, right? There's 180 degrees in a triangle, right? So bear that in mind. Now, knowing that there's 180 degrees, I've got a triangle of sides 1, 1, and 1. What are the... Stop talking. Just listen. Inside of a triangle, there is 180 degrees. So if I've got a triangle of sides 1, 1, and 1, what are the internal angles?
I don't know.
You can't divide 180 by 3.
60?
Yes. So I've got a triangle of sides 1, 1, and 1. The internal angles, which have to add up to 180.
You don't have any. You don't.
The internal angles are shut up. The internal angles that need to add up to 180 are all 60. Right? So now, but knowing that, I've now got a triangle of sides 2, 2, and 2. So what are the internal angles in that triangle?
You don't have any evidence that Earth moves.
I've shown you lots of evidence, but you ignored it. But anyway, I've got a triangle. Knowing that in a triangle of sides 1, 1, and 1, the internal angles are 60. I've now got a triangle of sides 2, 2, and 2. What are the internal angles for that triangle?
But I don't see any evidence of Earth moving.
No, I've shown you it. But anyway, I'm asking you a question. I did, and you ignored it. I'm asking you a question once again. I just want you to try and be honest.
Where can I observe Earth move?
Stop it. I'm asking you a question.
I can't, can I?
I'm asking you a question.
You can't either.
Yes, you can. I'm asking you a question, so answer the question. Show that you're intellectually honest, because I'm gauging your level of intelligence.
No, because I'm right.
I'm engaging your level of intelligence. Just listen and answer the question. Shut up and answer the question. Shut up. Stop and answer the question. Stop.
You don't have evidence.
Michael, Michael, be quiet.
That's okay.
Michael, be quiet.
Okay.
I'm asking you a question.
All right, man.
Be a decent person for 1 second in your life.
You're asking a question about an irrelevant subject.
No, it's not irrelevant. It relates to this because I am testing your knowledge. So just listen. Just listen. Michael, shut the fuck up and just listen. Michael, just shut the fuck up and just listen. Michael.
This isn't a test.
Michael, shut up and listen. Don't shut up.
I thought this was
it's a test now, so shut up and listen. Right?
Okay, bro.
I've got a triangle of sides 1, 1. Michael, will you shut up? Michael.
I mean, if you can't debate the subject, bro, I mean...
Michael, shut up and listen. I've got a triangle of sides 1 and 1 and 1. The internal angles are 60.
I didn't come here for a test, bro.
Michael.
I came here to debate.
Yeah, and this is part of the debate. I am giving you a litmus test. I'm giving you a litmus test for the debate. All right?
You're deflecting because you don't have...
I've done the evidence. You haven't understood it. So now just listen and answer the question like a good person. I've got a triangle of sides... Shut up! I've got a triangle of sides 1, 1, and 1. The internal angles are 60. Now I've got a triangle of sides 2, 2, and 2.
You lost the debate.
Michael, I was nearly finished. Will you just listen? Wait until I finished and then you talk. Okay? Please. 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 All right?
Go ahead.
Got a triangle of sides 1, 1, and 1. The internal angles are 60. Now I've got a triangle of sides 2, 2, and 2. What would the internal angles be on that triangle?
have no idea.
Why not? It's
This
the
isn't
same
winning- this
angles,
isn't
you
winning your
dumbass.
debate. This isn't winning your debate.
It really is winning the debate.
It's not. This isn't evidence of Earth moving.
Michael, I've already won the debate by showing you evidence of Earth moving. You went,
Yeah.
no, it's fake.
No, you showed
Yeah.
me a video.
Yes, that was the evidence of Earth
Supposedly a
moving,
compilation of images,
which
from
is what a
space,
video is.
Which is there's no evidence that's from space. That
Yes,
could have
there is.
easily
It's
been
a
made
satellite
here
in
on
space
Earth.
that you can laser range.
You can laser range.
Yes.
When did you laser range it?
I haven't laser ranged that satellite, but that's
You're right.
that's a genetic
You haven't
fallacy once
laser
again.
ranged it.
Yeah, but
You
you've never
haven't
done any
laser ranged
experiments, Michael. You've never done any
see,
experiments. Michael, we're
Apparently,
now going to ask
everything that
questions
you-
from the audience.
All of the claims
Michael,
that you make
I have
have
answered.
to be true because they're true, even though you.
Right, you're muted because you're being rude. I'll unmute you in a second. Right? I'll unmute you in a second. When I'm talking, you stop talking. When you're talking, I'll stop talking. But you need to do the first part. Okay? I have demonstrated all of the evidence. You have ignored it, not understood it, or claimed that it's fake. Tony showed you lots of evidence as well. I've already won the debate. That bit is over. I'm now going to read messages from questions from the chat, and you're going to answer them. All right, please unmute your mic.
Right.
Nicholas Green says he's been a member for 21 months. It's a Monday takedown of stupidity. Guys, if you want a question for the Flat Earther, now would be the best time to get the super chats in. Don Carnage, member for 23 months, says, let's guess no evidence. You are correct. Henrobi, 5 years. Everyone's got their bingo cards ready. Mine is filling up quick. Dude, the bingo cards would have been destroyed. Every single one would have been full. Member 33 says, did you say you've been doing this for 10 years, Michael?
I haven't been doing this. I unsubscribed from heliocentric theory about 10 years ago. Yes.
And this this is your evidence, yeah?
What is my evidence?
None is the point. Right. Yeah. Thank you, Loop on Fire. Stop the Stupidity, gifted
Did we
5
observe
memberships. Thank you.
The surface of water finding its level.
I
And
showed
water
you the
doesn't find
surface
its
of water is
level or
curved.
require a container.
Level means curved. I've showed you the surface of water curves.
Level does not mean curved.
Yes, it does.
Curved
proof?
and level have two different definitions. They're
Do you want proof?
You're going to prove to me that two different words have the same.
Do you want me to prove to you that
definition?
according to all of the experts, the word level means curved?
Look at the
on
definition
Earth?
of the words.
Yeah, from experts.
Please bring up. Okay, how about you bring up the definition of the level curve of the word curved, and bring up the definition of the word level, and let's see if they're exactly the same.
Here we go. The definition of the word level by surveyors and experts.
Okay, no, I'm talking about the definition in the dictionary of the words.
Yeah. So the one that says that it matches the curvature of the liquid parts of Earth's surface. Is that the one you're on about? Merriam-Webster.
No, I'm talking about the definition. Like you can go to like a Webster's dictionary.
Yeah, I
look
bring up
level.
Merriam-Webster level. Let me just get that for you because you just actually dunked yourself quite hard there.
Yeah.
Because the Merriam-Webster dictionary it literally defines it as a curved surface.
Really?
Yes.
That's
Right, so here is Merriam-Webster's dictionary, the adjective of the word level, having no part higher than another, conforming to the curvature of the liquid parts of Earth's surface. Interesting that that's what the level in the dictionary is. Now here is experts that use the word level in their surveying manuals and stuff, showing the difference between... Yep, showing the difference between a horizontal line and a level line. So here is a book about surveying that talks about what level is. And it shows you
there's a
the
tool
level.
called a level as well.
Yep, and that is locally level. Of course, the plumb lines diverge.
Locally
we know
level,
that.
yeah, because
Yes.
level becomes different over distance, apparently.
Locally level means it will react to it is perpendicular to the pull of gravity at any point. That's what level is.
I mean, when you hold a level up to like hang up something like a picture,
yeah, so and
you know,
that's
use a
at
level.
that point perpendicular to the pull of gravity.
Is that
Yeah.
level flat? That
No.
tool that you're using is it
level
flat?
isn't flat. Level is not. Level is
the,
level.
The,
flat
the
is flat.
leveling tool that you use isn't a flat tool.
It can have a
That's
shell around
wild.
it that is flat, but
That
it's
is
not level. Is
insane.
not flat. A level level
pretty
line
sure that
is C.
level-
I'm showing you here. According to Trigonometric Leveling 11, which is a book used to teach surveyors, the level line is obviously C, whereas the horizontal line is B. Level line diverges from the horizontal line. According to engineers. A level surface is defined as a curved surface which at each point is perpendicular to the direction of gravity at any point. The surface of a still water is truly level surface. Any surface parallel to the mean toroidal surface of Earth is therefore a level surface.
Struggle with definitions. I get it.
I'm reading you the definitions right now. For the definitions, this is from Leveling 155, Chapter 8, and it says that for the definitions, it is evident that a horizontal line departs from a level surface because of the curvature of the Earth. Since the line of sight cannot follow a curved level line, an error is introduced and objects appear lower than they really are because level is curved.
Okay.
A truly level surface. This is from, let me see, what year is this? This is like from the 1800s. A truly level surface is a segment of any spherical surface which is concentric to the globe of the Earth. A true line of level is an arch of a great circle which is imagined to be described upon a truly level surface. The apparent level is a straight line drawn tangent to an arch or a line of true level. True level being the curve of the Earth. So everyone, even the dictionary and all these experts and books and surveying manuals and teaching stuff, they all show that level is in fact a curved line. Level surface being that dotted
level
line
as
there.
An adjective, and it says having a flat and even surface without slopes or bumps.
Yeah, here it is again. Of course, level can have different words depending on context. Words can mean different depending on context, but here it is in the Merriam-Webster dictionary.
Adjective?
I'm showing you in the Merriam-Webster dictionary where it says about conforming to the curvature of the liquid parts of Earth's surface.
We're using level as an adjective, right?
Yes, and it says having no part higher than another, conforming to the curvature of the liquid parts of Earth's surface. Do you see that?
No, I'm looking at the
I'm literally showing you on
level.
screen right now from the Merriam-Webster dictionary.
From when?
This is the most recent version of the Merriam-Webster dictionary.
Having no higher part than another.
Conforming to the curvature of the liquid part of Earth's surface, yes.
Parallel with the plane of the horizon, horizontal.
Yes, because
Even
depending
or
on the context,
in height.
depending on the context, well, height is obviously from a reference surface. So if I've got this is like, for instance, a tire is level to the wheel that it's on, right?
I sent a link to a tool. If you could bring up that the picture of that tool that I sent you.
The word level. Is a tool the word level?
It's a tool used to level things out.
Yes, which work because they're perpendicular to the pull of gravity.
Could you bring up the picture of the tool and we can discuss if that's flat or curved?
Yeah, that is perpendicular to the pull of gravity at any one point.
That is, it's level.
Yes.
Flat.
Over that short distance, it might appear flat. Do you know
what do they use in the level
to what margin of error
flatness?
To what margin of error is that flat? That edge there. But what we're looking at, the actual level is the bubble, which reacts.
The bubble, yes, it's the water.
Which reacts to the pull of gravity.
No.
Yes. That's what makes that bubble go in the middle, is when you have it perpendicular to the pull of gravity. So thank you for proving my point. But anyway, yeah, level means curved.
Nothing to do with gravity, but okay.
It's literally to do with gravity. That's how it works. Right. Anyway, next question. All right. Can't
rely on the explanation.
Well, it's what the experts use to teach other people. So F dot has been a member for 2 months.
Right?
No, gravity's not a theory.
theory?
No, it's not.
It's a scientific theory. Yes.
There is the scientific theory of gravity, just like there's the theory of music or the theory of driving. Gravity isn't a theory any more than music is a theory.
In science, there's scientific facts, laws, and theories.
No, scientific theories contain facts and laws.
No, scientific theory is an explanation.
No,
That's
scientific theories contain facts and laws.
A scientific theory.
No. You're arguing with a person that does science about what science is.
You do science,
in science, a theory.
Right?
No, shut up. In science, a theory contains facts and laws.
Yes, but at its core, a theory is an explanation.
Yeah, it could be containing all of the facts and laws.
That's all a theory. It's just an explanation.
Yeah, of the mechanics of something, like driving
But
theory.
It's not.
Shut up. Listen to the words. Shut up.
Damn.
Music theory.
Man.
Music theory explains all of music. It contains all of the facts about music.
Yeah,
Driving
different
theory contains all of the facts about driving a car. I had to take a driving theory test when I got my license 25 years ago.
It's different in scientific definitions, but okay.
No, the scientific theory of music is the theory of music.
Scientific theory
Yes,
is an explanation.
containing all of the facts. All of the facts are part of the scientific theory.
If it was repeatably observable through experiment, it would be a fact.
All of the facts are in the theory. Theory contains all of the facts.
A theory isn't factual.
It is the factual.
explanation.
A scientific
An
theory
explanation.
contains all of the facts. Why aren't you getting what I'm saying? Is music a
Because
theory? Is music
how
a
can an
theory? Is music a
explanation
theory?
contain all of
Is
the
music a
facts?
theory? Yes or no?
How can an explanation
Is music a
contain all-
theory? Yes or no?
It can't be a
Is
scientific
music a
fact
theory?
and
Yes
a
or no?
scientific theory
Show that you're
simultaneously.
intellectually honest and answer the question. Is
You
music
don't
a theory?
understand the difference between
Show
a theory
that
and a
you're
fact.
intellectually honest and answer the question. Is music a theory? Yes or no?
Yeah, you can have a theory to music.
Is music a theory? Yes or no?
Sure.
Music's just a theory, is it?
I mean, it's observable, repeatable.
Yeah.
You can listen to music. So it's pretty
So
factual
why is
that
there the scientific theory of music?
It's a study of music.
It's the explanation of music that contains all of the facts about it, like how to perform a chord, how to do an arpeggio chord, what harmonics you have, how to separate
A scientific fact and a scientific theory are two different things, though.
Yeah, a scientific theory contains all the facts. That's the thing.
Does it?
Yes.
It contains all the facts,
Yes.
but it's an explanation, right?
That contains all of the facts.
An explanation that contains all of the facts.
Yes.
If it contained if everything in the theory was true, then it should be repeatably observable through experiment.
It is.
Well, then why isn't it a scientific fact?
There is the scientific facts of gravity. They're part of the theory of gravity.
Okay, haven't seen those, but okay.
Right. Okay. Anyway, back to so we got Stop the Stupidity gifted 5 memberships. Thank you. F. member for 2 months says no part of the water in a bathtub is flat. I know. I showed him water being measured curved. He's ignored that plenty of times.
Water being measured curve.
Yeah, I literally showed you water being measured curved and having a drop from tangent at 8 inches per mile squared by a professional. Darren Discord, who's been a member for 56 months, that is the love bot. I predict that by the time Rogers reads this, that this guy will still have given no good points and give no evidence for the damn. No, he gave nothing. He didn't even understand why you have to, what the formula for weight actually means. It's incredible. Jim Daniels, $5. Ping pong ball versus water in microgravity. He's not going to believe anything from NASA. So we can show him how water acts when there's no forces acting on it, and he's not going to believe it because it's from NASA, because he likes committing the genetic fallacy. F. says $4.99, all the water in a tub curves. Have you ever measured the water in a bathtub? Yes or no, Michael?
No.
Right. Have you ever measured water at all?
I mean, I can see with my eyes that
Your eyes aren't a measurement. Have you measured it? Yes or no? Don't answer a question I didn't ask.
Yeah, I mean, you can see it's flat and level.
Yeah, your eyes aren't measuring. Have you ever measured water? Yes or no?
When you look at a horizon, is it
Have you
horizontal?
measured water? Yes or no?
Is a horizon horizontal?
Yes or no? Have you measured water? Yes or no?
I don't need to.
Yes or no? Have you measured water? Answer the question. You're being intellectually
Unnecessary.
dishonest again.
I'm not.
You are. Answer the question. Yes or no? Have you measured water?
Have you observed water sticking to the outside of something?
Yes. Earth.
Like a large body of water sticking Earth. And where
Yes.
did you observe this?
I looked at through satellites.
You went to you saw the pictures.
I saw the live images from space.
Got you. Yeah.
Yeah.
Had to be live images from space. No way that they created those or photoshopped them. Or
But if you've got evidence they did, that's great. But
compiled
have you
images of
measured? It's yes or no
Why do I
question.
need
Have you
evidence?
measured water? Yes or no?
Well, you've
Have you
never
measured water?
observed-
Yes or no? I'm just going to keep asking you.
you've
Have you
never
measured water?
observed
Yes
a
or no?
large body of water stick to the outside of.
Yes, I have. Right, I'm going to mute you, and I'm going to ask the question, and then when I unmute you, I want you to either say yes or no, like an intellectually honest person would. Have you ever measured water? Yes or no? Please unmute and answer.
No.
Right, okay. Well, someone else has, and he showed that you were wrong.
Well,
Anyway,
who did? Who did?
Jesse Kwazowski, I showed you him doing it. Golf Ball
some
Turbo
data
2.
that he supposedly.
Yeah, I showed.
from
There's
his
videos of it as well. You can look up I can send you all the details, and it's been repeated on video as well. Ball Turbo 2000 for $4.99 says, "Why would objects sink without gravity? Why not move towards the North Pole? Why not move towards my taint?" Why do objects sink at all if there's no force pulling them down?
The downward vector is caused by incoherent dielectric acceleration. It's
No,
more
there's
like
not.
Things
There-
falling
there's
into place.
that would mean it was different depending on a different material, and you don't get that.
What do you mean it's not dependent on things being different material?
If it was through
Which is by
dielectric
electrons,
magnetic acceleration, yes,
there's
it would, because that would be at
100 millivolt.
No. Let me answer. I'm going to just keep muting you if you talk over me. All right. There is no measurable downward acceleration due to electrics, right? And the 100 millivolt per 100 meters thing that Witsit Light's going on about actually dissipates after about 700 meters, yet things above that still fall at the same rate. So no, that's not true, right? So, I'll unmute you now. If you start talking over me when I'm talking, I'm just going to mute you because you need to be treated like a child quite clearly. Please unmute.
Yeah, this is crazy.
F Grudge says for €2, why is the Flerf talking about maths? What is his highest level of maths education? So F Grudge has asked for €2, what is your highest level of mathematics education?
High school.
And what grade did you get?
Don't remember. I don't see how math is.
So you failed then, is what you're saying?
Well, math. We're talking about the shape of the Earth.
Yeah, maths is needed for that.
Use all the numbers you want.
Yeah, how are you going to measure something without maths?
Observations. Well, you use numbers in
Yeah,
measurements.
that numbers are maths, dude.
But
Derek,
when you're observing something, like a large body
yeah,
of water
like when I can
sticking
look
to
for
the
a
outside
satellite
of
and
an
observe
object.
something, but you don't like it because reasons. Now shut up. Derek the Dullard, £5.
No,
My name is Craig. Shh. Don't be rude. People have paid to have this said. Derek the Dullard for £5 says, my name is Craig McNeil, and Nathan Oakley is my best friend.
Hello, I'm Nathan Oakley. I like getting pegged with a pepper grinder.
That's not very... Nathan, have you got anything else you'd like to say?
Hi, my name's Nathan Oakley, and I have been lying to people about the Earth being flat for a lot of years. I did this to hide the fact I have a small penis.
Very strange, Nathan Oakley. One of your Papa Flerfs, it seems, but you're probably too dumb to know who he
I
is.
have no idea who that is.
Yeah, of course you don't. Yet you've said the bunch of things that he said verbatim. Rachbot, member for 78 months.
In my life.
Incredible. Outstanding destruction. All hail Craig and Tony, by the way. So your life, how old are you, Michael? Just out of interest.
There you go. Assassinate my character now.
No, I just asked the question. How old are you?
37 years old.
37. And what do you do for work?
Work in a warehouse.
Doing what?
Union job.
Yeah, doing what in a warehouse?
Operate heavy machinery.
Like what?
Like electric pallet jacks and forklifts, stuff like that.
Right, okay. And you married?
Yeah. No.
Single?
Yeah.
Well, makes sense. Kids?
Yeah.
And yet you're
Just
not with the
graduated high
parent.
school.
You're not with the mum, so you couldn't hold up.
No.
Okay. Yeah, weird.
No, there's a lot going on there.
Yeah. I've
I don't
been
see
married
what-
for 20
this has-
years.
I don't see what this has to do with the debate. It's
Nothing.
like-
I was just wondering. It was just actually just an inquiry. Nothing to do with the debate. It was just me asking you a question.
Right. Okay.
Max
Are you-
for 30 UU says, "Did you know PhD Tony is my father? Ask Flerf." Michael, this Max wants to know if you know what 1 times 1 is.
I really hope your dad calms down. He seemed like he got, he's gonna have. I thought he was gonna have a stroke. To be honest with you.
No, he's good. He's used to doing that. It's fine. But what do you know? What 1 times 1 is? Someone's paid to ask you that question.
Yes, it should be 1, according to modern math. Even though multiply means to,
Sorry,
Like,
are you disputing 1 times 1
multiply it.
equals 1?
Yeah.
You've got one group of one thing. Means that you have what you're. Are you saying that you think it should be 2?
Some people do.
Like who?
If you're going by modern math standards, it'd be 1.
By all math standards ever, 1 times 1 has been 1.
Yeah, people have different ideas,
Like
I
who?
said,
Who's got a different idea?
People have different ideas.
Like who?
Everybody has different ideas.
Who's got a different
like I
idea
said,
about 1 times 1?
According to the education system's modern consensus of how math works, it'd be 1. Okay,
Who disagrees that it's 1?
people. I'm sure there's a lot
Name
of people
somebody.
out there that would disagree. I mean, do I know the names of everybody on Earth that doesn't think it's 1? Am I supposed to? You don't think there's people out there that would disagree with it?
Terrence Howard, because he's extremely dumb.
I mean, yeah, I'm sure there's some people out there that would not agree with it.
And they're retarded, to
I'm
be
not saying
clear.
Great, bro. I mean, I didn't say I disagree
You're
with
kind
it.
of retarded, to be fair.
Well, I mean, if that's how you feel.
I mean, it's not how I feel. You've observed that fact here today. Unless this isn't unless you're like, if you're some kind of amazing actor, now would be the time to tell us. Because you have played the part of one of the dumbest people I've ever had on my channel very well. And to be clear, I've had close to 2,000 Flat Earth debates.
Great.
No, in fact, I've had close to 2,500 Flat Earth debates.
And
so,
your best evidence is satellite imagery from NASA.
No, it's the measurements of the Earth.
The measurements of the Earth.
Yeah, and the people
that
go
you didn't
into
take
space.
Yourself.
I've measured the Earth
And
myself with a
going to
pendulum,
space,
of course.
Yeah, because you've been to space.
No, but it doesn't matter if I've been to space or not. I've still measured the Earth.
Yeah, sure, yeah, but
yeah, I went through how I did it anyway. Goofball Turbo 2000 for $19.99. Thank you very much, my friend. I do appreciate it. I am FTFE, and I will cook Emily a nice meal and serve her all the iced tea she would like. I'm not saying this because of a super chat. I mean every word of this. I swear upon the flying spaghetti monster. Look, Emily lost the chance for her monthly food when they decided that going to work would be more important than watching this stream. I let them out of the basement for one day and they go to work. You think they're getting fed? Don't be stupid. What do you do with the captives in your basement, Michael?
I don't have any captives in my basement.
Where'd you keep them then?
Don't have any captives at all.
Sorry, I don't understand. What do you do with the people you kidnap?
I don't kidnap anybody.
Why not? Well, how'd you get your menial tasks and stuff done?
Do them myself, I suppose.
You can get people for that. You just kidnap them and keep them in a hole under your basement. I get.
I guess that's what you do, man.
Are you telling me like you fill the dishwasher and stuff yourself?
Yep.
What? Guys, are you hearing? Oh, fuck's sake. This is crazy shit. Like, people go missing all the time. Just take one. There's lots of them. There's nearly 9 billion out there. You can just take one, dude. They're just there. Fuck's sake, idiot. Henrobi for €5. Maybe show him how you get from FG equals GM1M2 over a square to FG equals MG by plugging into number. I took him through the maths, Henrobi. He didn't get the maths. He doesn't even understand that 180 degrees divided by 3 is 60, and that 1, 1, and 1 is the same as 2, 2, and 2 when you're talking about the angles of a triangle. That would be pointless. Myself, the other, who's been a member for 38 months, says, weight is relative to the gravity of the object's mass. Fuck, this guy is dumb. I'm now stupider because of intense exposure to the radioactive stupid. I know, guys. Well, what do you expect from a flat earther? There's two options. One, he's an actor and a Poe. Two, he is in the top 3 of the dumbest people I've ever spoken to. If he's an actor, I'm sure he'd tell us by the end of this. If not, there is the other option. Gary IOW for £2 says, Michael, what is your favourite Kardashian?
I don't watch the Kardashians.
Okay, what's your favorite Cardassian?
I don't even know their names. I couldn't tell you.
Golden Cut. Oh fuck, what are the other ones called? General Tegan. There's a bunch of Cardassians. The guy that kidnapped Picard. What about him? Do you like him? Do you prefer Golden Cut before or after he got possessed by the Power Wraith?
The what?
Golden Cut. Do you like him before or after he was possessed by the Power Wraith on Bajor?
I have no idea what you're talking about.
What do you mean? You not watch Deep Space Nine?
No, I don't watch television, to be honest with you.
You're a weird person. Mad Mike for £5 says, analogy, sandwich equals bread plus filling. No filling is just bread. That r/whoosh, no, he wouldn't get it. Deplorable ilk for £5. Can the Flerf tell me the difference between 4 and 4 times 2? Guys, have you got any questions for the Flat Earther? Now would be the time to send in the super chat and ask. Yeah, what is the difference between 4 and 4 times 2, Michael?
4.
Yeah, and how did you get that?
Multiplied 4 times 2.
Which gives you what?
The difference. A difference of 4.
Right. So 1 times 1, what would be the difference there?
1.
There would be 1. Oh my god.
I mean,
there would be a difference of 1 if you times 1 by 2. You fuckwit.
Yeah.
Armageddon, $5 super sticker. Thank you very much. Dr. Apocalypse for £5. The 4-kilometer long tunnels for LIGO are raised about 1 meter at each end to account for the curvature of the Earth. Otherwise, the lasers wouldn't reach the end. Yes. Have you ever heard of LIGO?
LIGO, is that a large? It's a large something. It's not like a large hadron collider, is it?
No, it's a large interferometer. Big ass laser. That 4 kilometer long arms, right? That are vacuum sealed, so there's no bending of the light inside them. So to make sure that they are completely flat, not level, flat, they actually deviate away from the curvature of the Earth over that 4 kilometers.
Do they?
Yes, the engineering project literally taken into account the curvature of the Earth.
And he watched this thing get built, and he can confirm that.
There's videos of it being built.
And in the videos, they walk around and show you.
There is videos
exactly
showing that, yes.
Where it dips and going down. Yeah, sure. Okay.
Tech Lore Knight for $5 says his whole shtick is if you personally don't know someone, they're lying, mixed with Dunning-Kruger, personal incredulity, and distrust of academia. Yes, it is. I absolutely understand why he's single. Pat in the chat, who's been a member for 54 months, says, "Oh brother, this guy stinks." Greater Sapien, I've already read that out. Thank you. Brawler, who's been a member for 45 months, says, "Dude, how do you think your car calculates its speed? Does it put markers on the side of the road and use a stopwatch?"
No, it has tire. It monitors the revolutions of the tire, like a speed sensor.
How does it do that?
It's connected to the the rotor, counting how many revolutions that rotor makes. It knows the size of the tire
relative to what?
To the ground. So it knows every revolution it moves.
Sorry, you think it does it relative to the ground?
Well, it knows how, with every revolution, how much ground.
No, it doesn't measure the tire relative to the ground, Michael. Shut the fuck up. You don't know what you're talking about. Jesus Christ. Pat in the chat for $10. No, Michael, just, you're embarrassing yourself. Stop.
Counting the revolutions.
Not relative to the ground, no. Relative to a point on the car.
I said it knows how much distance it's moved over the ground with each revolution.
How? You said it measures the revolution relative to the ground. No, it doesn't. Anyway,
counts the revolutions.
Michael, just, you're talking to an engineer. Just stop. You're embarrassing yourself. Pat in the chat for $10. Earthrise and the accompanying original photos from that mission and all other Apollo missions are analog. They cannot be faked. We live on a globe. Yeah. How did all the photos
from Star Wars in the 70s and they didn't go to space? All that was filmed here on Earth. That's a film.
The
What
actual,
makes-
but there's studios for that.
But
the actual, the pictures from Apollo, the pictures and videos from Apollo, we have the pictures. Shut up. The pictures and videos from Apollo, we have
You
the
couldn't
originals
take
of
those
it. Shut up,
same
Michael.
pictures on
Michael, shut up when I'm talking.
You could.
Michael, shut up. We have the pictures and videos from Apollo, the originals that we can check, and we can see that they were not in a film studio. Whereas when you look at the originals from the Star Trek, the original video and tape and stuff, you can see all the stuff that they had to then make into post-production. Raw videos cannot lie when it's analog.
You can definitely take those same photos here on Earth. You could set up a small studio and take photos like that on Earth.
Yeah, okay, but then you would have to A, remove all the air from the studio, and B, change the gravity in the studio for the physics to match with what you see. I've done the analysis on that. So Andreas Elditch for 56 says, please explain to me, Michael, how you can tell the speed of the car if you're laying down in the back seat and looking at nothing but the floor.
Look at the speedometer.
No, you're looking at nothing but the floor of the car.
But you're in an enclosed system, so you wouldn't feel it. 'Cause you're in
Oh,
an
you
enclosed
wouldn't
system.
feel something if there was constant movement? What if the car moved left or right? Would you feel that?
Yeah, you'd feel it then.
Would you feel it if it sped up or slowed down?
Yeah, you'd feel that, yeah.
But if the car was just moving at a constant speed with no variation, would you feel that?
Yeah, if you're in an enclosed system, no, you probably wouldn't feel it.
Yeah, and gravity makes Earth a closed system, because Earth, according to science, is a closed
The theory,
system, of course.
The explanation encloses Earth.
No, according to Earth, according to science, gravity and everything makes Earth a closed system. So thanks for debunking yourself. Mr. E-Man Original for $5 Australian. Can you provide your personal analysis of the recent Artemis photos?
I mean, like I said, those photos could easily be taken here on Earth.
The ones that were live on an iPhone through the window showing space, that could be taken on Earth, could it?
Film that on an iPhone.
All right, we'll recreate it then. If you want to challenge science, the way that you do it,
and I'll fucking I'll recreate anything they can do, bro. I mean, I don't have NASA's budget, but okay.
If you can't recreate it, you can't challenge it. Then
give me 50
you can't prove that it's fake. You're just saying
I'll fucking do it. I mean, it makes some pretty interesting movies.
Yeah, but they use that money to pay their
a day.
employees. That money gets used for things. Do you know how many people? Do you know how many people NASA employs?
A lot.
18,000. Most of the wages go to either that or paying contractors.
Or buying helium.
NASA use helium for fuel storage and stuff.
Yeah.
Yeah. Do you know that the first time we found helium was in the sun?
Really?
That's why it's called helium.
When they went to the sun and found the
No, they
helium
used
there.
spectroscopy and discovered helium.
Oh,
That's where it got its name, and then we discovered it on Earth.
Ah.
Takoa 0815 for 5 years says, as a surveyor from Germany, I'd love to hear what flat earthers have to say about the Gauss-Kruger coordinate system. Do you know what the Gauss-Kruger coordinate system is?
I don't.
No, of course you don't. Ronald van der Stam for €5. I have a formula. TikTok science squared times dumbass equals Flerf. I can't argue with that. Dapper Dinosaur, a real dinosaur in the chat for $2. Asked Michael, is an angle real or fake? Kapla. Michael, is an angle real or fake?
An angle to what? An angle's real.
Is there any dirt in middle?
Is there what?
Is there dirt in middle?
Is there dirt in middle?
Yeah. Is an angle real or fake?
I mean, an angle would be a theoretical concept, but like you could use an angle to measure stuff. I don't know what your point is.
Thank you, Michael. That's going to make a good clip. Mr. Hankey, who's been a member for 11 months, says, what's the angular size of this dumpster fire? You could calculate it from far away with alpha equals 2 times the arctan of G over 2R, of course. Michael wouldn't understand that. No dirt in middle. No. Andreas Elditch, who's been a member for 23 months. Dude, nearly twice around the sun. Don't flurf and derive. F Grudge for €2 says, don't take your cup home. Don't tell me what to fucking do with a cup. Stupid concerts. We're going to another concert on the 15th of August, my wife and I. Replay concert. Going to actually see like fucking Blue and Bewitched and Natalie Imbruglia, Top Loader. It's going to be pretty fucking badass, actually. Ronald Vanderstamp for €5 says, can you ask Michael why mariners and airplane pilots use great circles to navigate the shortest distance between 2 points?
Do they?
Yes, as a sailor, I can confirm that, of course.
They use the globe to find the shortest distance between 2 points?
Yes, the pilots do, and anyone sailing a boat uses great circles to find the shortest distance between 2 points.
So, if I flew from California to Qatar, the shortest distance would be to go over like the Pacific, right?
It would, if you were looking at it on a flat map, it would look curved because the Earth is curved.
Now, if you look at it on a flat map, which I did take that flight last year, and I went straight over like the North Pole.
Yeah,
I went straight over Canada, over Russia, and down into Qatar, and it was a straight line.
Straight line on what? On what projection?
If you put it on compared it to, which isn't used for distances, but the
which projection of a map did you use?
A Gleason's map.
The azimuthal equidistant projection map. Yes, that's the only one that it would look straight on. On every other projection, it looks curved because it's great circles. But of course, distances aren't right on that, so we can't use that to determine what the actual shape of the Earth is. Inquisitive Infidel for $5 says, what experiment would provide evidence to change your mind about flat Earth, Michael?
I guess measure the curve over a long distance of water.
Which I literally showed you that being done, of course.
You didn't.
I literally did show that from Jesse Brzezowski. I showed you the surveyor doing it.
1800s.
No, I showed you the surveyor doing it and from now. Remember over the mile of water? Jesse Kozolski, I showed you the
mile of water.
Yeah, I remember it turned out 8 inches per mile squared drop from tangent. I showed you that.
And how do you know his equipment was set up properly?
Because he's a surveyor.
Oh, he had to be perfect, right?
That's his job. I imagine he would know how to set up his equipment, yes.
So
again, if you doubt it, get a theodolite and test it.
Okay.
Inquisitive Infidel for $5 says, Mike, when did you lose control of your life and why wasn't it your fault? What are you doing now to gain control of your life and what makes you so special?
I never said I was special, and
you're definitely special, but back of the bus, licking the windows, short, kind of special. When did you lose control of your life?
I didn't.
You would have a stable family otherwise, but okay. So why wasn't the problems in your life your fault?
I never said the problems in my life. What problems are you talking about? You're just making assumptions about me. Like my life sucks. It doesn't.
I mean, doesn't sound that great to me.
Why you get this idea? You think because I don't believe the same things that you do that my life sucks?
Well, no, just the general attitude from you would show that your life sucks. Bill Tetley for $5.
I haven't
Michael, the mentally deprived.
I'm
talking.
I'm not.
I haven't called you names. I've used descriptions.
Okay.
Mike, Bill Tetley for $5. Thank you, Bill. Michael, the mentally deprived fucking idiot, never grew up past high school because he wasn't going to let the man hold him down. Man. Thank you, Bill.
Right.
Grug, 100 Nokias. Where did you find this baby Flerf? Who is his papa? Well, he's definitely done Oakleyites. He's definitely got Witsit stuff in there with the dielectric acceleration. There was a bit of Dubé, and I think I might even sense a tiny bit of Dell in there. But I think Witsit is probably his strongest papa Flerf.
I've never watched Witsit in my life.
Yeah, you have.
No.
He's literally the one that came up with the dielectric acceleration thing.
Dude, I let go of heliocentric theory back in 2016.
I don't believe you.
Making any content, but you don't believe me?
No.
So
I think you're lying about that. I think you're either lying about being a flat earther, or you've been doing it for a couple of months.
Social media posts in 2016. There's not going to be anything about a flat earth.
I don't believe you.
You don't. But if I go back to my social media in 2017.
I just don't believe you. I don't believe that you've been studying flat earth for 10 years and you can still be this much of a baby Flerf. It's not possible. Bill Tetley for
Only
$10 says, Michael must be a Greg Opie Hughes fan and subscribes to the talk quality in the background while others are trying to talk because he can't stand being silent, lest he be forgotten about. Don't worry, Michael's definitely forgotten about.
I'm not worried about being remembered at all.
You won't be, apart from as that idiot on FTFE's channel.
Yeah, I got you. So I see this wasn't really, this hasn't really been a debate. This has just been like a lot of like name calling.
Well, it's been a debate. I've showed you evidence and explained why you're wrong about
You
everything.
made claims.
No, I showed evidence.
You showed papers from people.
Yes, that's evidence.
Claim to have
Yeah.
done things.
That's evidence,
But you
yes.
didn't show any evidence.
I showed lots of evidence, including a surveyor doing his job. I showed the Earth being measured. I showed lots of evidence. Just because you don't understand
Didn't show
it,
the
you're
Earth
the one
being
that showed
measured
no
at
evidence
all.
and made claims. I showed actual receipts for all of my claims, including what level actually means according to all the experts. Inquisitive Infidel for $2.
According to
PhD
the
Tony,
experts.
we are shut up. PhD Tony, we are Spartacus. Science has his defender. Tony, I do appreciate you coming on, mate. Dapper Dinosaur for $5. Hi, I'm Craig. Sanguinus is my favourite Primarch in Star Trek. I especially liked it when he used Exterminus on Tatooine via the TARDIS death ray. I will find you. You know that, Dapper. I will find you. JSS Tiger for $5. Why don't Flat Earthers know geometry? Yeah, why don't you understand geometry, Michael?
It's too advanced for me.
I believe that. JSS Tiger, $5. Sleeping Warrior doesn't do equilateral triangles. Chris UK thinks angles add up to 135. Nathan Oakley can't convert to kilometers. And Michael doesn't know why you have to times thing by 9.8 meters squared. Just Rick for $2. Michael is impervious to knowledge.
Yeah.
That's just a fact. F Grudge for €2. What is Michael's favourite brand of butt plugs?
What the fuck?
I don't know, he's a weirdo. JSS Tiger, $5. Somebody mail this guy some flashcards. 1 times 1 equals 1. Henrobi for €2. There are 4 lights. Picard or Kirk? Michael, Picard or Kirk? Is the Enterprise A better or the Enterprise D?
I don't know what you're talking about.
You disgust me. Hugh Josh, who's been a member for 51 months, asked the Flerf why I can't zoom in on the sun at midnight with a telescope.
It's too far away.
How far away is it exactly?
Too far for your telescope to see.
So are the
know,
stars
any
closer
object-
or further away than the sun?
I haven't measured the distance to either because I haven't been to either one of them.
But which one's further away, the sun or the stars? Because you can see the stars at night,
Yeah.
so they must be closer than the sun, right?
I mean, they could be close to the same distance away, but
If they're the same distance away, we'd be able to see the sun.
Than the stars
They
are,
have to
so-
be closer than the sun. If the reason we can't see the sun is because it's too far away, yet we can see the stars.
Yeah, they're probably a little bit higher.
Well, that's further away, which means we shouldn't be able to see them.
What do you mean you shouldn't be able to see them?
Well, if they're further away than the sun and we can't see the sun, and the reason we can't see the sun is because it's far away, then we shouldn't be able to see the stars either, Michael.
What do you mean?
Think, McFly. Goofball Turbo 2000 for
the sun is constantly
$1.99.
moving.
I'm reading out someone's paid for this. Be respectful. Goofball Turbo 2000 $1.99 says, Michael, what is the circumference of flat Earth?
Can't measure it. I have no idea what the circumference is because
Why not? You've got the same tools we do.
If you're talking about like how many miles across Earth is, we'll never know because you're not going to Antarctica. You'll never know what's past that 60th parallel.
You can go to Antarctica. A lot of my friends went to Antarctica. I've been to Antarctica.
I can't go to Antarctica. No.
I've been to Antarctica. You can go to Antarctica.
That's great. I mean, can you go there by yourself?
Yes, you can. Many people
Explore
do.
freely?
Yes, many people
Really?
have gone across the whole thing on their own.
Who's gone there by themselves and just freely explored without any permit from the government?
They're,
Just gone.
a
Just on their own, didn't get
22-year-old did it
stopped
last
by-
year.
Did he?
Did she? Yes.
How'd that go?
They went across the entire thing on their own with no one guiding them and no one stopping them going where they wanted to.
They just no one stopped them. They just landed in Antarctica and
Yeah.
just had all the equipment to travel across the whole
Yes,
thing?
they did. Yes.
They?
You can look it up if you don't believe me.
Doubt that. Oh, they made a story about it, so it's got to be true.
Well, they
Couldn't
had
be.
GPS tracker on them the whole time. JGB12121974 for $5 says, could you tell us what 3 is? No, he couldn't. Abdef, who's been a member for 50 months, says, thanks to Craig and Tony and everyone in chat. Tonight has been such enormous fun. Guys, we're getting through it. We're nearly there. And afterwards, there's a redirect set up to go to MC Toon. So please stay in the chat. If the redirect works, it didn't yesterday. Wyatt Laderut for $4.99 says, hi, FTFE. Nice to see you later. Nice to see me later. Am I seeing you later? Have we got a meeting? Are you using time travel again? You know NASA gets mad when you do that. Ernie Matthews for $5. Hi, I'm Nathan Oakley. And when Craig is in town, I take my teeth out and pray. Flat Earthers do run away from me in real life, just like Witsit, of course. Earthrise, who's been a member for 55 months, says almost 5 times around the sun, and Flerfs still exist. I know, it's crazy. Thank you for being a member for so long. Tom WEZX for $4.99. How dare you mention spectroscopy? Everyone knows spectroscopy needs a container. Do you know who David Weiss is, Michael?
I have heard of him.
Yeah, he's a complete and utter scumbag liar, so you probably shouldn't listen to him.
I don't know him personally.
No,
I don't know.
I do. He's a scumbag. The Gordon Captain for $2 says, Mike effing magnets. How do they work?
Magnetism.
Yeah, how does magnetism work?
Positive and negative.
The Antarctic traveler's name was Tilo Cruci, by the way. Whale Panties for $4.99 says, such a bad Flerf. I don't even want to know what his favourite shark is. Yeah, you don't get to answer the question what your favourite shark is. You don't deserve it. Odin's Rage for $5. This Muppet has much in common with young Earth creationists and, oddly enough, mole people believers. How old's the Earth, Michael?
I don't know.
I do. Rudolph for $2. Yeah.
How do you know the age of the Earth?
Carbon dating. Rudolph for $2
dating,
says T or F.
were there.
Edu equals indoctrination. Is it true or false, Michael, that education equals indoctrination?
I believe it can be. Yeah.
Well, you wouldn't know because you've never done education.
A good student does what? Repeat what?
Not
they're
what
told
you
on
did.
tests.
No, actually,
But
a
you're
good student doesn't repeat what they've learned on the
you're
test. A good
rewarded
student
for
demonstrates their
getting
knowledge
good grades.
practically. But you
listen
wouldn't know
to
what a
the
good
teacher
student is,
tells
Michael,
you.
because you're not a good student. JSS
Blindly
Tiger for
listening to
$5
what the
says he
teacher
wondered
tells
if circumference was miles across globe Earth. All right, guys, that is all the super chats. I want to say thank you very much for the support. It's been a great stream. There was like 500 of you watching at one point. Absolutely brilliant. I do appreciate it. Michael, well, one more from White Lad Root for $1.99. Hi, I meant to say it's nice to see your life. Do you mean live?
My life.
Thank you. He's talking to me, not you.
Oh.
So, Michael, why are you so fucking stupid?
You know, that's a great question. You know, calling people stupid when you lack evidence to support your claim.
Oh, no, I've shown you lots of evidence. You're just
Weird
ignoring. You're
debate
pretending I
tactic.
haven't given you evidence because you're
Very
stupid.
Weird debate tactic.
I gave evidence. You're just too stupid to notice it.
No, I just think your evidence was.
Well, that's because you're too stupid to understand it.
You're accepting that the images that NASA shows you are real.
Well, you need to show that they're not real.
I don't need to show that they're not real.
Yes, you do. If you're claiming they're not real, you need to show that.
I mean, they're images that NASA created and showed you, and you're just accepting them as true.
Have you got any evidence they're not true?
I mean,
no, you don't, because you're stupid. If I was going to be nice to you, I would call you a fucking idiot. But that would be being mean to fucking idiots.
I mean, that's a real great way to debate.
I'm not. This isn't. The debate's done, Michael. I'm just telling you a fact. You are. Well, again, I'm not going to call you a fucking idiot because that's not fair to fucking idiots. They're much smarter than you.
Great, bro.
I imagine you were fed lead paint instead of formula as a child. It's not your fault.
You can imagine a lot of things, and you're entitled to that.
Yeah.
But at the end of the day, you don't observe Earth
Michael,
moving
you're
any
not
distance over time.
You're not stupid. Michael, you're not stupid because you're a flat earther. You are a flat earther because you're stupid. This is just a fact.
Right.
I've demonstrated how stupid you are here. No, in fact, you've demonstrated yourself how stupid you are. You are aware, sir, to quote PhD Tony, that you're doing this in public.
And that means what?
Thousands and thousands of people are going to see you do what you've just done.
I don't care.
I get close to 1 million views a month. People, there's so many people are going to see you be this fucking stupid. Your kids could come online and see their dad be actually functionally retarded.
I haven't been functionally retarded.
You certainly have been.
I don't know. Well, I mean, you keep saying that, and if you
you demonstrated that you were functionally retarded. I'm not. I've been here for close to 4 hours.
The entire time.
In the past 4 hours, you have demonstrated that you are functionally retarded. I think it's possible you need a crash helmet and supervision to go across the road.
Well,
do you wear slip-ons or Velcro?
I mean, you can keep calling me names, and
I haven't called you a single name.
Believe it. I don't know.
Michael, is it Velcro or is it slip-ons?
I'm sorry you feel that way.
Is it Velcro or slip-ons? Is Velcro too complicated for you?
Man.
Where did it go wrong for you?
It didn't.
It clearly has. Was there a point did you have some brain damage a few years ago or?
It's amazing. You keep saying I have brain damage and.
Well, yeah. I mean, you can't be a flat earther without some kind of brain damage or mental disability.
And this is based on, and this is all based on because
this is based on my conversation with you.
Because you believe that the imagery NASA showed of Earth is real.
Yeah, it is real. I've checked.
You checked.
Yes.
You went up to space and you.
Oh yeah, I went yesterday.
Earth moving.
Yeah.
Yeah, that's what you did.
Yeah, yesterday.
No, you didn't.
I went up yesterday.
And you never will. That's the thing. You're never going to go to outer space.
Yeah, I went yesterday.
Nobody,
I'm in space right now. We're all in fucking space. Everything's in space.
You can't go to that imaginary place that only exists in your head.
It's certainly not imaginary. Space is just where the atmosphere gets thinner and thinner and thinner. Are you denying there's a gradient in our atmosphere, Michael?
It's a place you're
Michael,
never
is there
go.
a gradient in our atmosphere, yes or no?
Yes.
Therefore, space is real.
No.
Yes, because that's just where it gets really thin. There is a certain point where the atmosphere is thin enough that we call it space.
And you've been there?
No. Doesn't matter if I've been there or not.
Have you ever seen gas pressure next to a vacuum without a solid barrier between
There is no
two?
gas pressure next to a vacuum. There is a gradient.
There's a gradient. Okay,
Yes.
but there's air pressure here where we're at, right?
Yes, which gets less and less and less as you raise in altitude
you
until
can't
it's
have
practically
pressure
zero.
without a container.
Gravity
cannot
makes
have
it.
any
Gravity is the
pressure.
container.
You're using a theory.
Gravity's not a theory.
It is.
No, it's not. Gravity is a fact.
It's not.
Yes, it is.
Okay.
Just look online. Google, is gravity a fact? And it will say, yes, it's a fact.
Yes, because Google is the source of truth for everything.
Where'd you get your information?
And it has to give you, have you ever tried to use gravity in an experiment?
Yes, I used it in the Cavendish experiment.
Okay. Well, how come you could take two objects with the same mass? One will sink and one will float.
We went through that.
Are
you resetting again? I've literally talked you through the maths with that.
Yeah, you did. You tried me through the maths where you had to use density, right?
Because that's one of the variables in the buoyancy equation. Yes, correct. Which is rho, not p. You fucking dumbass. Right, Michael. Have you got any final thoughts that you'd like to tell everybody?
Results with or without the force of gravity, though.
No, you don't. You literally need the force of gravity. We went through this.
It's the same number.
No, it's not the same
exact number for the force.
Michael, have you got any final thoughts? Yes or no?
It's been fun.
Don't care. Go away. Jesus Christ, that guy was dumb. Right, guys, I'm just going to double check that I have set up the redirect to Tune properly, because apparently the one I did yesterday did not work. Yep. Right, Tune's about to go live, going over some Mikey activism. Thank you very much for being here. I do appreciate it. I love every single one of you. Not you, Gary. You know what you did. Amazing stream. Great amount of super chats. You know I really appreciate it. So hang around in the chat. But before we go, I do need to ask a really important question. And that question is, can we pretend that airplanes in the night sky, I don't know, Wait, shit, where is it? I've released so many videos now, it's really far down. Can we pretend that airplanes in the night sky are like shooting stars? Thank you, guys. I'll be back tomorrow with a debate between Toon and a Flerf. See you then. Remember, stupidity is not a right.
Can we pretend that airplanes in the night sky are like shooting stars? Should be wishing for a brain right now, brain right now, brain right now.
Good morning. These words come with a storm warning. Better batten down the hatches, grab some matches and brace yourself for a long day of misery. YouTube has given me the power to reach up into the sky and show you all that we live on the ball. I bring you science that's comprehensible. Your view is indefensible. You're reprehensible. No one's too sensible. When I was young, I never thought I would be here to see this. A pile of random nonsense dressed up as bullshit. Your ignorance will be the death of us all, like running head first full speed into a wall. You could always read a book, buy a telescope, set it up and take a photo of the moon, or just be a buffoon. I send you in a balloon up to the stratosphere in page 3.
You're a few fries short of a happy meal. You're dumber than a box of hair. The wheel's spinning but the hamster's dead, and you're as smart as bait. You forgot to pay your brain bill. You're missing a few buttons on the remote control. 24 cents short of a quarter. You're surfing in Nebraska. You're as bright as Alaska in December, and you fell out of your family tree. You don't have all the cornflakes in one box. You got an IQ of 2 and it takes 3 to grunt. The elevator doesn't go all the way up, and there's a vacancy on the top floor. Your antenna doesn't pick up all the channels. You're several nuts short of a
You're Mr.
fruitcake.
Sensible, calm down, don't go too hard. You don't need the atlas burying Flerfs in your backyard. You're a man of science, poise and grace. Mage 2 did everything to wipe the grins off the face. So Nathan, get away from those kids. The world is not flat and it doesn't have a lid. Recognize the differences between the textbook and the Bible and control yourself. Lay off your slander and your lies. You're a bunch of knobs poisoning the well of the youth. Spreading lies that you like to claim as knowledge and truth. Stop spreading fresh bullshit like the butter on your bread. Maybe a musical assault and knock some sense into your head. I hope one day you'll hear these lyrics and smile, and you realize you used to be a 40-year-old child. Now it's time to wake up, open your eyes and see, and acknowledge the existence of.
You're a few clowns short of a circus. Your phone is off the hook. Your sewing machine is out of thread. You're all foam and no beer. You don't have all your dogs on one leash. An intellect rivaled only by garden tools. There's no grain in your silo, and your skylight leaks a little. Your belt doesn't go through all the loops. You couldn't pour water out of the boot without instructions on the heel. Your slinky's kinked, and you're proof that evolution can work in reverse. A few feathers short of a whole duck, one fruit short of a full bowl.
Airplanes in the night sky are like shooting stars. Should be wishing for a brain right now, brain right now, brain right now. Can we pretend that airplanes in the night sky are like shooting stars? Should be wishing for a brain right now, brain right now, brain right now.
You thought it was over? Well, I'm still standing while you're swinging, flinging feces, talking shit just like the human centipede. You got the mind of a chimp, and I'm here to expedite your shore leave. Cause I'm a seaman, but not the kind I writ up on your mom's gums. I'm the kind that sailed submarines and fired guns. I could float a boat across the ocean with my eyes closed, circumnavigate the globe with a compass and a bag of sausage rolls. Well, all you can do is nibble on your toes. I smack you with the hose that you call a water level, sit and swivel. You nasal gazing muppet, you can stuff it harder than the wallet stuffed by Warren Buffett. And I don't care about your sauces unless you're serving them. And I don't care about your lines unless you're curving them. Now step away from me, you're sucking up my oxygen with the vacuum where your brain should be, you dumb fuck.
Thank you guys for watching, I do appreciate it. Do not leave the chat, you'll be automatically redirected over to Toon. What an absolutely fantastic stream of old, that was just pure gold. Expect to see lots of stuff from it soon with shorts, thanks to Emily trapped in my basement. See you soon, go over to Toon, I'm going to go to bed. Remember, stupidity is not a right. Fight the flat earth.